All right, I want to thank everybody for joining us today at the HELICS Users and Developers meeting. It is hard to believe that it's been approximately a year since we met. Another virtual year, but this is great because we can see at least folks across the Teams meeting here and hope to make this a pretty engaging meeting. Really want to spend some time kind of updating everybody on all the kind of changes that have happened with Helix over the last year, and then have a discussion throughout the course of the next couple of days about the use cases that we're focused on, get all your feedback that we can. We really want this to be a very interactive meeting, so never feel bad about interrupting. Between the 5 or 6 of us on the Helix team that are on the call, one of us will always be monitoring the chat and answering questions if we can't during the middle of the presentation. We are going to record this all and then make it available on our YouTube channel at the end of the sessions. So feel free to go back, and if you miss something, then you'll be able to pick it back up later. So just really quickly, what's the agenda for this week? Of course, we're virtual, so that means we can kind of do some things a little bit differently than we would have in person. So we're spreading it out over a few days. Today, we'll focus on just some really kind of quick updates in our current planning and what's going forward. Then we'll jump right into what we're calling our project showcase, which we're going to show off a bunch of projects that are outside the core Helix team that are using Helix, give them a chance to really kind of show off some of the cool things that are going on right now. That's a chance for everybody on the phone to have discussions about these projects, find out folks that might be doing some things similar to yourself, form collaborations and partnerships, fully encouraged. And so take that advantage and time to use to kind of make connections and just find out all the interesting stuff going on. The last hour today we'll spend on usability. We took a lot to heart about what the TRC and folks told us last year from the users community about how Helix was hard to get started with. And so we've spent a lot of time working on that, working on some other features around compatibility and standardization. So we'll talk to you about the progress that we have there. It's not 100% there yet, but we've made really great progress. So we'll talk about where we're headed next and hopefully get some advice on what are the most important things from you. Wednesday, we'll dive into some use cases that we've been using to develop Helix over the last 2 years. And so we'll just dive into those in more detail, talk about the lessons learned from those, talk to you about the code that we're providing out there for folks to use so that it's not something that's just lost or anything like that. And so we'll dive into I think it's about 7 or 8 use cases at this point now, once you subdivide some of them. And then we'll talk the last kind of 2 hours on Wednesday. We'll talk about core development. There's been a whole bunch of feature changes. We've migrated to version 3.x over the last year. And so there's been some pretty large changes. Hopefully not too bad on the compatibility side, but underneath the hood, they've been pretty significant upgrades that we'll have Phil talk about. And then on Thursday, we have set aside time for the technical review committee to sit down and have discussions. We'll note that on the note I sent out a few weeks ago with the agenda, I was doing time zone math incorrectly. And so this is now out there at 9 o'clock to noon on Thursday Pacific time. But for those TRC members, you should have received a calendar invite. If you didn't, just shoot me an email and we'll get that to you. So just a couple of ground rules. This is absolutely, feel free to ask questions. Most of the sessions are designed to be conversational, and so please use that. As you see down here, if you're not familiar with Teams, I hope everyone is by this point, but if you're not, there's just a few icons here to take a look at. There's the chat window where you can ask questions in text. There's the raise your hand function, which is really helpful. Like I said, we'll have folks keeping an eye on that, making sure that if that pops up, we'll interrupt the presenter. Obviously, when you're talking, if you want to use your video, great. You don't have to, but it's great. I like seeing faces. I miss it at this point. I'm excited to go out and see people again over this next few months. And of course, if you're not speaking, we are recording this, so let's make sure and mute your microphone. If the background noise does get too high, we may have to mute you directly, and that's too bad because then you can't unmute very easily. And we're going to do our best to stay on time and have a few breaks in between to make sure that we're not just all sitting at our desks the whole time. But we're going to continue any conversations that make sense to do so, because that's what we're here for. We're here to chat with the community, learn, and hopefully share a lot of good information. So just a little bit of background, just brief history for Helix. This was started in 2016 under the DOE's Grid Modernization Lab Consortium, or the GMLC. We created the initial tool called Helix, and it was really bringing together the fact that there were a bunch of national labs working on different source codes that were doing essentially co-simulation in different frameworks and different ways. And it was, really noted that the best thing to do is to collaborate, to work together and bring it all under one umbrella to form kind of a best-in-class open source solution that all the national labs were using and that we were then able to share with the community. That had a 3-year time run, which was wonderful. We were able to get the tools off the ground, really get it going, kind of got the core and application layers pretty well defined. But then, in 2020, so just at the beginning of the pandemic, DOE released a second set of funding for us, which has allowed us to focus on what we're called the Helix Plus project. So if you see those two different terms, the Helix is the core software, Helix Plus is the project that we're using to develop it on right now. And really, we've been focusing much more on kind of the usability, some of the application layers, integrating more simulators, and really just trying to improve the way that Helix is used across the community. And what's exciting is we've made a lot of progress. We're going to share it with you as much as we can this week. But of course, there's always more to go. And so we're happy to hear where we can improve on those things. And of course, if you want more information, we do have the helix.org site, which has a lot of kind of basic information around models that you can use. It has things around example codes. It has documentation, which you'll see has been significantly improved as we go through this, but also we'll link you over to the code and downloads and things like that. So just, one kind of a clarification on what we're talking about when we're talking about co-simulation is really the idea that we're trying to analyze large and complex systems by unifying different code bases. And so, it's basically the idea that you could build an Uber model that will combine domains, look at a whole bunch of different things. But in this case, we're actually looking at ways of bringing existing software models and different domains and concept of times all together in a coordinated fashion. And these models and software don't have to be written in the same language. They may or may not be running on the same computer or operating system or even in the same network. And the co-simulation allows these tools to talk to each other and have interactions in some kind of common format. And then, the key is really influencing each other's behavior so that when a change in one simulation occurs, it transitions over to the other and back again. And so really, at the heart of it, this co-simulation tools essentially manage two things, which is time synchronization. So if your simulator doesn't have an idea of time, then it has to be kind of modified to help do that, or it can be used to kind of think about time in a different way. And then it manages data exchange. So that's at the heart of it. That's everything it does. Now you'll see that that's the start, and you'll see that as we've progressed with Helix, of course, we've created a lot of things around that to help users and ourselves manage those things much better, and hopefully, and so you'll see a lot of those kind of things as we go forward today. So when we start thinking about what Helix itself brings to the table, it really is designed to be a high-performance co-simulation engine where we're really focused on the energy space. There are general co-simulators out there. There's ones that have been designed to be compatible with FMI and things like that. But really, we wanted to focus on something that was designed to be in the energy space and really focus on those tools in there. And so you see, we started out with transmission, distribution, and communications as being one of our kind of key features. But as you see, as we go through the use cases today, we've really extended that beyond to things like to natural gas simulations. We're looking at building simulations, transportation simulators, and various other things across the board, including Opal RT and RTDSs. And so the library of combined tools is starting to get quite large, and we're super excited about where that sits right now. And the whole idea of what Helix is then able to do is then be able to bring those into multiple platforms, scale it up to, we hope by the end of this project, somewhere in the neighborhood of a few 100,000 federates simultaneously, which could be, thinking about, say, a combined T&D system with thousands of controllers on it. You could very easily get to hundreds of thousands of federates. And then you can mix and match these tools, use the APIs that you're most comfortable with. Of course, you'll see that we've adopted a Python API as being our most common one, but we still support these kind of underlying languages too. Completely open source, so take it and use it however you would like. And then really kind of looking at different ways of combining simulations, which is including discrete event, quasi-static time series, and dynamic. And then doing what we call a co-iteration, which is kind of tight coupling of systems, which means that you can basically iterate back and forth on two simulators and really focus on, in that case, like for example, a T&D solver where you want to split up the solutions and solve them simultaneously. Phil will go into a little bit more about our release cycle, but we certainly have version 3.x available at this point. And I think this week 3.2 will be out, and so then we'll be able to share some of the details about that a little bit later. So just really quickly, the overall Helix Plus team, we have a lot of kind of exciting partners on this. P&L, Livermore, and NREL are kind of the lead core team, also working closely with Argonne and Idaho National Labs. And then we have partners that are actually kind of our first users on these tools. So Washington State University, Avista, NRECA, SIME, Inga, Clemson University, and Idaho Falls really kind of being the first, Uncord, really kind of being the first users of these tools and helping us develop some of the interfaces to the platforms that they need in terms of their investigations. And then, of course, this team that we have here represented a really strong industry and advisory board. And then always have to thank our funders, of course, Solar Energy Office, Systems Integration, Office of Electricity, and a big thank you to all of our cost share partners here also. So what we're going to talk about a little bit, there is a structure to our project, and so we're going to kind of follow that. The three areas that we're focused on was basically increasing simulation methods, increased usability, and then demonstrating the value through use cases. And so you'll see as I go through here, we've broken this into 4 tasks that align with those 3 areas, plus coordination and outreach. This slide deck is going to basically, I'm going to go over this very, very high level, how we're doing on each of these areas, but then each of the presentations throughout the next day and a half will go into a much more detail. And so first, I just want to summarize what we learned last year. Obviously, this is super high level. At the TRC user group meeting, there was a lot of key takeaways that we had. We tried to make it primarily focused on the users and developers and get your feedback. We had 3 day sessions, roughly about 60 participants when it all came said and done. And of course, we had the TRC meeting that allowed us to get direct feedback and things like that. We ended up getting something like 12 or 13 pages of notes, and so we really appreciated that. But just kind of when I want to sum it away with 3 or 4 of the key things. The takeaways there, there was a lot of excitement around standardized domain APIs, which would allow us to basically transfer information at say like a distribution solver, A or B. They basically look the same to a transmission solver once you get into the into the system itself. And so that's a way to kind of help more quickly integrate new tools. But we also heard, if we had to figure out kind of who we're focusing on here, because the way that the tool was set up, it wasn't quite easy to install and use yet. And we got the suggestion that if you're targeting an engineer to utility, it really needs to be much more of a click and install. But if it's targeting vendors, it needs to be more kind of at the code base, because the vendors are going to be wrapping it with their own products. And so that was something that we took to heart, that we had not threaded that needle very well. And so hopefully you'll see some improvement this year. One of the huge advantages that we heard was the ability to connect to simulations and systems without accessing the underlying data models. So basically people could obfuscate the other half of the system if they wanted to. And that's something that we've continued to allow to be part of the tool. And then, we heard a lot of what I call the chicken and the egg problem. We needed to hear for the vendors to integrate to the tools, we needed the request to come from the utilities, but for utilities to adopt, the tools needed to be integrated. And so, that drove us to hear a lot of comments from folks that we just really need to focus a lot on use cases that continue to drive the interest and show the value of the system. And so, hence the reason we're going to have this big project showcase next, because that's super exciting, and we can hopefully get to those things. And so, the interest of time, I'm going to go through these next few slides fairly quickly, but they'll be available for folks afterwards. So task 2, which is really the core development features, which is basically building the core itself. This has been a lot of focus on kind of driving up scalability, actually observing, executing, and debugging larger co-simulations that have caused some challenges, quite honestly, in terms of timing. We've discovered timing bugs and things like that Phil and his team have worked through. We've created a whole new layer for diagnostics and debugging, because that was something that came up last year during the meeting, was that it was kind of a little bit challenging to do that. And so there's a lot of kind of interesting, exciting stuff going on there. We've got the 3.x version of Helix out, and we're continue to release kind of new versions of that every month or two. And as you can see, we're seeing a lot of kind of traffic across the GitHub site, and a lot of kind of downloads of Helix, which is exciting, and hopefully means that folks are getting a good use out of it at this point. What's coming up for this next year? We've got about 7 or 8 months of funding left in this year on this project, and so before we look at to DOE for a kind of next round of possibilities. So what's our big thrust for this next 7 months right now, of course, this is all subject to what we hear over the next 2 days, is to really kind of focus on FMI integration and make sure that we're kind of aligning with standards that are out there, and we can work with other tools that use FMI. We're going to look at some dynamic federation challenges, or actually upgrades is probably the way to say it. Is basically, can you dynamically assign federates rather than having a static model? I always think of that one as the one where, if can you bring in an EV that's driving around your distribution system and parking at different locations as a different agent? And so you have to kind of plug into different parts of the simulation depending on where you are. Lots more debugging. That's something we're just going to keep focusing on. There's new profiling features, breakpoints, and debugging queries and messages. We're going to keep expanding those. And then kind of a big thing that we're going to focus on over the summer is really kind of scalability and orchestration. How do we start to scale towards potentially even millions of federates, and then being able to do that across a wide platform? And what are the tools that enable that? Because that becomes a bit of a data nightmare just to even get the things all talking right to each other. So task 3 on usability. So we've had a significant overhaul of the user's guide. Thanks to Trevor and his team there, and Deepak. We're working really hard to kind of say, hey, we need to make sure that the person coming in who wants to start using Helix, they know where they fit in the puzzle. So we kind of broke it down into 4 user types: an analyst, a modeler, an integrator, and a developer. So depending on where you sit in that kind of groupings, then you can get geared towards the right documentation. And so at this stage, we've really been focusing on the integrator modeler level, just because that's the kind of ones that are engaging right now. But of course, over the next year, we hope to kind of expand that and help grow that documentation base. And so just a couple of expanded examples. We've expanded our example suites. So basically trying to find ways that we can put code out there so folks aren't starting from scratch, and be able to start from things that have already been done and shown to work. And so we've created a library of different expanded example suites, so that folks know both how to understand how different pieces of features work within Helix, but also then oh, here's what an EV model looks like, and here's how I might be able to do something with that. And so there's a lot of those out there now. We'll continue to build that library. These libraries also become some of our testing features, so we make sure that the code is staying pretty solid, but it's something that we continue to build out. The other piece of usability that we're really continue to focus on, and we'll have some discussions about later today, is the standard APIs, about how we're exchanging information between the different simulators. We're not requiring that you use this, but we are making it available, and something that we are adopting internally as a way of standardizing the exchange information. You can always go back and go down to the root itself and build your own. But we've really tried to kind of adopt a certain set of things that allow us to be a little bit more common interface, both across what we call the Pythonic interface and across the information that's exchanged. And so Trevor and Deepak and others will go into that over the course of the next 2 days here. And then, of course, what we're planning to do on this is really basically show it. So we've got some basically demonstrations coming on these. For example, being able to switch out SIME, OpenDSS, and GridLabD, but not have the transmission simulator even know the difference. Things like looking at some of the data exchanges and usability targets around standardized interfaces, and then continue to grow out the suite of features and tool sets and examples that folks can get part of. And then you'll see today, later today, the expanded web interface that allows us to do some kind of limited interaction with the simulation while it's going, and being able to kind of graph the data, check how things are going, and also get kind of runtime construction of federates. And then we will continue looking at how we're going to do workflow and data management tools. I think there's no simple answer for that one, but we are looking at ways that we're going to kind of coalesce on certain ways of doing that over the next 7 to 8 months. And then task 4, which will be the use case session that you'll see tomorrow morning, is really, these are kind of driven through both demonstrations and partnerships to kind of further Helix development, engage with folks as a way of discussion around what are the outcomes and how does these different tools integrate together. And so you're going to see these 6 use cases, like I said, plus there's a couple of variations of each of these at this point that we'll go through in a lot of detail tomorrow. And I hope that's pretty exciting for everyone, because it, to me, is actually the most exciting part of the outcome of this product. So with that, that ends this first initial session here. And so we've got a couple minutes here for folks to either take a break or ask questions before we get started at the bottom of the hour here for our next project showcase. So I'll leave it open here for the next 3 minutes for any questions, or if anyone wants to take a quick bio break, then this would be the right time. Then Brian, I think while we're making this transition, if you want to start pulling up your slides.
Yep, yeah, I'll plan to have those up. Just want to make sure people feel comfortable speaking up right now.
Jason, this is Craig. Are you getting wide support from all of the DOE offices?
So I think so. I think there's a lot of support for having a common platform and common tool that a lot of folks are using. And so at least at this point, yeah, we've got pretty widespread support, both for the baseline, just kind of keeping the tool active, but also continuing to develop out the capabilities that align with specific use cases.
Are they pushing any specific use cases they'd like you to move into?
I'll ask the rest of the team to jump in on that one too, but I think one of the big ones has really been on transportation integration. Start thinking about what does that mean. I've heard a lot about communications and understanding how those things, and then as part of some of our resilience efforts, natural gas integration with grid.
Okay. What about resilience issues of DG?
Yeah, that's a good question. We are certainly using the tool for that. It hasn't been a big push at this point from the sponsors that are funding Helix, but at least internally, we have certainly been focusing a lot of those. I know, Kevin Schneider, of course, has some good work going on right now with integrated T&D to look at multiple microgrids. You might be familiar with the concept of, a certain hexagon system that looks like a beehive.
Yes, I'm looking familiar with that. So.
But that is certainly something that he's been implementing inside of the Helix and GridLabD engine. So,
if there were 2 National Academy reports in the last couple of years. One was on resiliency, and the other was on the future of the grid. And unfortunately, they did them in reverse order. I think they should have envisioned the future first and then talked about resiliency. But there's a thread running through all of them that resiliency is going to be based in large part on the distribution side, because that's where most failures are happening, and that distributed generation can be a major factor. So I'm glad. So Kevin's doing that work, huh?
Absolutely. Yep.
Good.
And of course, I'm speaking about P&L there. So if Brian who probably can chime in and talk about the other
I'm
ones.
sure the other labs are doing something brilliant as well.
Exactly.
Okay.
Yeah, there's definitely lots of interest, and you'll see some highlights in some of these upcoming project showcase, as well as kind of a continued interest across the board. I think you're right that the DER and resiliency have been common themes, but we're also seeing some pretty big excitement just around the sort of T and D interactions, which maybe is not surprising. That's in some ways how we started, but there's certainly still plenty of unanswered questions there.
Okay, good. Thank you.
Thanks, Craig. Appreciate that. All right. Well, if no additional questions, I think we'll jump right into the session that I think folks will be very excited to see. And so, Brian, if you are ready to go, it's all yours.
Excellent. Yep. Take a second here to bring up the slides. But as we get started with that, I just wanted to highlight, as has been described already, that what we're doing here today is doing a little bit of a project showcase to highlight some of the uses of Helix beyond what we're doing within our project directly. And so that's kind of the exciting point. This is people who aren't necessarily directly working on this team, in general or not, and they're making some good use and some very exciting use cases or really projects that are making, like I said, making use of Helix. So for those of you who were here last time, last year, we had this as a bit of a lightning round. Thankfully, this time we have a little bit more time allotted. So in fact, we have a total of a couple hours available. Sorry, it's taking me a second to get, there we go. Slides show up. And I'll sort of talk through that schedule in just a second. So thanks everybody for attending. You can see all the slides here. Just to highlight in the agenda, you saw this from Jason just a half hour ago, but some people may be just joining now. We're in this project showcase, and I know there might have been a little bit of confusion between the project showcase and the this upcoming use case session. That one is tomorrow, and that's going to focus on the use cases that are within the Helix Plus project. You saw Jason have a quick list of those as part of his presentation. So just same slide as before, please ask questions, raise your hand. You can use the chat window, and we'd love to see people's faces in this virtual world if you're able to. And so really the goals of this project showcase are, to showcase projects that are beyond what we're doing directly. As you know, you'll start to hear some of these themes throughout this workshop the next few days. We're really trying to look at, as we round out sort of the last really kind of less than year of this current project, kind of looking ahead to what's next, what can we do better, but also what would it take for wider spread adoption, in the industry and beyond. And so very interested to hear any comments that may come up from those spaces, as well as Jason highlighted, one of the main goals here is to just showcase all this work to start to encourage any collaborations and connections among the researchers and the folks doing this type of work. So here's our fairly packed agenda of what we've got going. In general, there's about 5 minutes for each of the presentations, plus a couple minutes for Q&A. And you can see we have a mix of lab and industry partners here, which we're excited to have. And as I mentioned before, we are going to have a little time here at the end, kind of the last 20 minutes or so, to have a discussion, talk about these gaps and opportunities as I highlighted in the last slide. Also, if you are sitting there saying, oh, shoot, I wanted to be part of this and I forgot to send those slides in or respond to that email, I did leave a few minutes there at the end of the formal scheduled presentations for folks who might be in the audience and wanting to kind of quickly highlight something they're doing in their organization. So without further ado, turn it over to Andy on the Good Apps D team. Andy, are you able to join us? I can't quite hear you right now. Wasn't trying to jump the gun on you there. All right,
And I don't actually see Andy on.
All right. We can skip Andy's slide and come back unless somebody else from the team wants to try to cover this. All righty. Well, let's zoom ahead a couple slides. Alok, are you online and able to talk about this work, exciting work on the AI engine for optimized service of mixed fleet transit operations?
Hi, Brian. Hi, everyone. It's a great opportunity, and I got a good amount of understanding of the progress with the Helix development as such. So, thanks for this opportunity, and I will briefly touch upon one of the use case of Helix for co-simulating the transportation systems with the electric grid. And this is a project that is led by Carta, and we are looking at the impact of transit system electrification. And so this project involves a lot more than co-simulation with the grid, but I will give a brief summary of the whole project and talk a little more about where Helix is involved and what we're trying to do with the integration to the grid. As you can see, the project team is fairly large, and some of the participants are in supporting roles, and some are leading some of the major tasks of this project. I would like to highlight that I'm the newest member on the project team, and I have Malini also on the call to answer some of the questions that I might not be aware of. So can you go to the next slide, Brian?
Sorry, jumped ahead too. There you go.
Sure. So this project deals with developing intelligent transit system operator assistance. So it involves various modules where we are looking at live feeds from the cameras mounted on the buses to kind of understand the passenger count and also help with respect to scheduling the transit system. And it also involves a lot of work on looking at developing operator assistance module that is almost a live assistant that can take into account live requests from some of the customers of Carta that might be requiring specific assistance like ambulatory services and some specific requests, and build those into their scheduling and day-to-day operations. So, and we are also looking at connecting the transit system electrification to the grid and analyze the impact on how this would result in terms of the losses, in terms of the grid performance, and eventually tied back into an optimal scheduling of the transit vehicles in terms of optimal charging schedules, but also looking ahead into the real-time markets and trying to see if we can get some feedback from the electric buses and the charging infrastructure into making these optimal decisions for an end-to-end transit system operation. Can you go to the next slide, Brian?
Seems to be jumping again. There you go.
Sure. So here we have shown the use case of where we are actually using Helix. So a lot of my involvement in the project was to develop this interface with the transportation simulation software called Sumo. It is also open source simulation software where it can integrate the GTFS data and also combine it with a lot of the transportation routes with detailed modeling, including the traffic simulations. So we are integrating this with the distribution grid modeling software developed by PNNL, which is GridLabD, and it's fairly widely used and has a detailed modeling capability to go down to the house level of modeling in the distribution grid. So we have identified some of the prototypical feeders that were developed as part of other DOE projects, and use some of these prototypical feeders that resemble the actual grid in Chattanooga region, and integrated the electric vehicle charging stations on the distribution grid. And we are actually combining this with the transportation simulation layer to integrate the electric vehicle charging and those simulations in a more tightly coupled way. Can you go to the next slide, Brian? So these are some of the preliminary results where we are studying the impact of charging of the electric buses on the grid. And this is a work in progress. We still have a little way to go to do a complete end-to-end transportation grid co-simulation analysis. I would be happy to take any questions.
Awesome, thanks. Yeah, this is definitely some exciting stuff for sure. And we have, well, a couple minutes for questions. So if anybody has a question or two, feel free to go ahead and speak up. I'm trying to get to the point where I can actually see other people raising their hands. I prematurely closed Teams. So go ahead and speak up if anybody has any questions.
Go ahead, Craig.
Yes, I don't want to dominate here. Anybody else who has a question, interrupt me. I look at the tool and I think it's very useful for proving the feasibility of EV charging and to sketch the general outline of where chargers would be sited and how they would be used and how they would be scheduled. But I don't see how this would be used immediately for answering specific questions as the utility is facing day-to-day issues. Do I open this facility or not? When do I schedule it and so on? Could you speculate on that? Because I'm sure you're going there.
Right. Yes, I think we are looking into those analysis, and the starting point basically with this project, which was funded by Vehicle Technology Office's Energy Efficiency and Mobility Systems program. So they wanted to look at the integration of EVs to the grid from a more transportation and that kind of flavor. But we are working on a few other proposals and projects at the lab where we are looking at it from the grid side in a more detailed way to understand how transportation electrification and integration of light duty, medium duty, and heavy duty electric vehicles can impact the distribution or the transmission system planning. And some of the tools that we are developing here are also forward looking in terms of trying to integrate it with a real time market scenario to understand how would the electric vehicle charging respond to grid price changes, and can we also combine it with other kinds of DERs to do a coordination between the DER operation and the electric vehicle charging. So can we utilize, and we are also exploring to answer a few questions of can we utilize the grid connected EVs as distributed storage. So
Excellent.
there are,
I think that's
yeah.
great. But can I ask a quick follow on? I know we're put on time, but different EV manufacturers are not, as far as I can tell, pursuing a common grid interface to receive that price information and to act on it. Are you or are you or somebody else working on standards for EV communications and integration and operation?
Right. So I am a power system engineer, so I'm not directly working on that right now, but I think I'm partnering with a few folks, and we are kind of working with a couple of folks at the Argonne National Lab as well, who are working on Polaris, and we're trying to see if we can actually come up with and team up with the teams who are working on these standards of communication for the EVs and also for the autonomous vehicles themselves. So I think another use case of Helix could be to try and look at how do we integrate communication layers to simulate decentralized control for autonomous vehicles. And this is something that I'm trying to do a bit of homework myself and trying to see if we can get something formulated in a reasonably good way.
Good. People got to yell at you. Don't just say, "Oh, I'm a power systems engineer. I don't have to do that."
That's right. It's all in our scope for sure. Well, thanks, Craig. We do need to kind of move on to the next question. I do see that Nadia's got a question. I'm hoping we'll have a chance to get to that as sort of part of the panel pieces, or if we have a little extra time there. I'm also starting to guess that a theme of today's project showcase is going to be transportation and grid. I know we have a number of other those presentations coming up, which is exciting. It's fun to have a chance to compare notes. So just for the sake of time, and we may end up with a little extra if Andy is unable to join us. But I want to move on to the next project, which happens to actually be Nadia's presentation on the Gemini XFC project.
Yeah, thanks, Brian. So it's a pretty similar project where with a slightly different scope, but we're also doing transportation distribution analysis. So this is Gemini XFC. Its focus is extreme fast charging. Can you go to the next one? Thanks.
Yep.
So this is a collaboration between NREL and Lawrence Berkeley National Lab. So basically, we're using Helix in co-simulation between an NREL developed tool called PyDSS, which is a wrapper of OpenDSS that allows for more configuration of inverters, especially that's like important for grid scenarios where you have a high adoption rate of solar storage. So that's really helpful. Not only can you reconfigure your inverter controls, but it improves on the convergence time for those types of systems. And then we're using Helix to co-simulate that with Beam, which is a Berkeley Lab tool for transportation simulation. So that simulates vehicles across the Bay Area down to the individual vehicle level and where they're charging and where their destinations are. So basically what we want to do is take this co-simulation and evaluate not only what the grid impacts are with these high future adoption scenarios, but also if we can implement some smart charging controls to mitigate those costs of upgrades. And the reason we're taking such a wide area is that we feel that for some metropolises, people are commuting long distances, and you might even have, say, travel outside of just your workplace back and forth. And so we want to be able to capture that true mobility aspect of vehicles moving across regions. So we're using a realistic but not real grid model. And what that means is basically there was this project called SmartDS, and it took city layouts and parcel data and determined how a grid could have been implemented in such an area. And so it's very realistic, used a lot of different validation statistics to make sure that these grids look true to what a real grid would look like in those areas, but it's not the actual grid implementation. So this is nice because it means that we don't have to keep our grid secretive or have an NDA. We can just share it and anybody can run the same simulation. So the focus on XFC is going to be especially important for these high adoption scenarios because once you reach a certain threshold, not everybody can do the level 1 or level 2 charging at their home or workplace. So you're going to have those gas station type models as well as fleet vehicle charging stations. So that's where the vehicle controls come in because this high adoption rate is going to put some stresses on our distribution systems. So can you go to the next slide? So the way Helix really enables this type of simulation is through a disaggregation of simulation. So we have, to capture the whole Bay Area, PyDSS works with, well, when you break it down into many different individual instances of PyDSS. And so we have 646 instances of PyDSS to capture our distribution system, but Beam works better if you just have everything in one large simulator, so it can capture vehicles traveling throughout the region. You don't necessarily want to break that up. So we have PyDSS on NREL's internal HPC and Beam running on a high memory node on AWS. And the flexibility of broker structures allows us to communicate across those HPC resources. The other aspect that helps a lot is that we started to hit some of the broker communications limits. And so we created a broker hierarchy. So you'll have one broker for a subregion, and then they all communicate with the master broker only for the information that's necessary to cross that Eagle AWS bridge. So between those two aspects, Helix has made this really fine, detailed, but large area simulation possible. So that's really exciting, and we're starting to get full-scale model data results back. I think that's it for me. Oh, I have one more slide showing. Here's some preliminary results. You can see how fine our distribution grid gets. So the zoom in is just of the Oakland-Alameda region, and we see a little bit of change in voltage on our distribution system once you add our lowest scenario of vehicle adoption for 2040. So this is cool preliminary data, but more polished results will be coming soon.
Awesome. Thanks, Nadia. Definitely an exciting project. I do see, Craig, your hand up. I'm not sure if that's left from last time or if there's, okay, it looks like that's coming down. Great. So, oh, it's coming up again. Maybe there's another question there.
Very quick question. I've been following it from the manufacturer's side a lot, and I think there's strong interest in solid state batteries, which are going to consume 3 or 4 times the power during charging. Have you looked at that? Or does that present any problems for you?
So the way we're considering fast charging is a bit of a broad definition. So we're considering it as any single location with above a certain power draw. Brian, do you remember? Thank you. So if that's one charger, that's considered XFCE in this project. But if that's like several chargers, which is what you would see even without those solid state battery configurations, then that's still considered XFC. So under that broad definition, you could consider the battery technology, but we're not modeling explicitly the battery performance in this project.
But a 5x jump in current would be a challenge.
So that's what we're starting to see with our preliminary results.
All right. Excellent.
Yeah. Yep.
Very interesting. Thank you.
Thanks.
Awesome. Thanks. Any other quick questions for Nadia? All right. Well, get my mouse back over here. Our next presenter is Trevor on TESP. And I owe Trevor an apology. He actually had hoped to present this last year, and due to a scheduling shuffle in our lightning round, I don't think we quite made it in. So glad we finally get to hear detail. I'm sure there's been some exciting updates since then.
Sure. Yeah. This will be a nice high-level overview of the Transactive Energy Simulation platform. The team you see there is just the current developers. There's been a whole suite of people, kind of too many to list, who have worked on it over the handful of years PNNL has been developing this. Let's go on to the next slide. So the Transactive Energy Simulation platform is or TESP. Its goal here is to try to provide a way to simulate transactive energy systems more easily. Transactive energy is kind of you can think of it as an incentive-based distributed asset management system, and it's a very broad umbrella, right? There's all kinds of different transactive energy mechanisms that can be implemented. One that we talk about commonly, it's if you just need something to hang your hat on, is what if the same kinds of things that are happening in the wholesale market were happening down on the retail market, and you could have an air conditioner in your house or a water heater or a clothes dryer or something, bidding into the market and taking advantage of low prices and avoiding periods of high prices. And ideally, if you do it right, you can still end up with the same amenity. The impact on your life is minimal, but the grid is being assisted, right? The peaks are being shaved and the valleys are being filled, all that kind of stuff. So this simulation platform that we're providing is at the heart of it is a bunch of tools that have been integrated via Helix. We provide examples as well that allow you to kind of see how we have done things, but it's a little bit of a very big sandbox in some respects. If you get involved with tests, you will almost certainly be writing your own code at some point, which is appropriate, right? If you're using it, hopefully you've got this new transactive idea you want to try to model, and nobody's done it before, right? So you're gonna take some pieces that we've already provided and customize them and write some new pieces and evaluate your system. The features that we provide there, as I'm kind of alluding to, we have Helix already, so that hopefully many, if not all, the tools you need, simulation tools, a transmission system, a distribution system, a communication system. We haven't got into the popular theme today. We don't have a traffic simulator in there yet, but maybe that's next on the list. I'll have to think about that. And then there's scripts for how you instantiate these models that you can customize, and then a common data collection and post-processing framework so that you can look at those results and graph stuff very easily. Go on to the next slide, Brian. Mostly it's just kind of eye candy. Here is in some respects the software architecture of the transactive energy simulation, and the star of the show in some respects is that black box at the top is Helix, that is tying all these different simulation tools together. I don't know if we need to necessarily get into the details here, but the point is this to show is Test comes with these tools. They're integrated. They're ready for you to use. And we've got there on the right are a bunch of what we call the agents that have been developed as a part of Test and are distributed freely and allow you to kind of see some of the common things that we've done in the past with Test. And again, hopefully to spur ideas and provide good starting points for what you're doing. Go on to the next slide. So just as kind of an example to show how, again, this transactive energy idea, here's an example for one of the analysis we did several years ago. It's kind of a classic one. Again, using that mechanism I was talking about. Here we see indoor air temperature, and this is probably average over a bunch of houses, several hundred houses. And then on the right-hand side, you see the price signal. The price signal is this dotted line, and you can see that in the non-transactive case, the blue line that you see happening there is what happens when your air conditioners are non-price responsive, and then the red line is what you see is happening, that the air conditioning gets deferred during the peak prices of the day, and then not deferred during the or rather catch up valley filling during the off-peak prices of the day to cool the house back down. This is looking at two separate days, and you'll notice the prices on day one are not near as high as the prices on day two, but the response is relatively similar. It's debatable whether that's a feature or a bug in this particular transactive case. The system was able to respond to relatively small changes in price on the first day and still provide value to the system. And on the second day, when these prices were much, much higher, it was also able to respond to a slightly greater extent and at its maximum capacity. And I think that is it.
Indeed. Thanks. Look at that. You're spot on time, too. Which gives
5 seconds.
Plenty of time for some questions, too. We'll go back to your last slide, too. I have a quick question for you, if no one else does. You talked about how there's sort of some different transactive types of frameworks that you might be able to look at. I was just curious if you could kind of quickly highlight some of those beyond the kind of classic canonical ones.
Yeah. So one of the other ones we are working on implementing, the work's already been done, we're just trying to suck it into tests, is what we call a consensus mechanism. And in that mechanism, it's a really privacy preserving mechanism. So no bids are submitted to any agent. Instead, the community as a whole, all the people participating, transmit to each other what they think, based on a local optimization, what they think the price and the cleared quantity will be, and they send that out to everybody. And as you might expect, everybody's first estimate or guess at what that will be is wildly divergent. but the mechanism is designed that through a number of iterations, a consensus is reached. And again, at no point you as a participant actually ever can communicate any private. You never communicate a bid. You never communicate how much you're going to use. None of that gets communicated. Yet the community is able to reach a consensus on that price. And we've shown that, at least with our example in one particular mechanism, that actually ends up being very close to, if not identical to, the actual mathematically optimal price for the community. So that's really interesting to me.
Yeah, cool. That's definitely an interesting case. Any other questions before we proceed along? All right, great. Well then, thanks, Trevor. Next up, we have Shin from INRO on the Cyber-Physical Dynamic Systems Modeling Project.
Hi, Brian, can you hear me okay?
Yes, thanks,
Okay.
Shin.
So this cyber-physical dynamic system is also using HELIX. We want to use HELIX to build a transmission and distribution dynamic co-simulation model to study the potential communication delay or failure impact of these DERs providing AGC services. So this is a project funded by OE. So first, OE funded 1 year, and we already finished this 1 year project. And this year, OE funded 2 additional years on this project. And at Unreal, basically me and Dr. Wenbo Wang working on this project, and Ladia and Deepak also provide a lot of support for this project. And we have a university collaborator, University of Tennessee at Roswell, provide a lot of support on the open source dynamic software like Andis to do the transmission system dynamic simulation. Next slide, right? So as I mentioned, this CBDS is to build a transmission and distribution dynamic co-simulation model as shown in the lower right figure. We use Helix as a co-simulation broker, and the transmission dynamics is performed in Andis, and the distribution simulation is in OpenDSS. We also built several other federates like a transmission operator, which means that's the federate to calculate the transmission network control signal, like to calculate the HT signal in the system level. And we want to build a DER aggregator federate to control the response of DER, like distributed PV, distributed storage, and electric vehicles. The information exchange is shown in the right above figure. You can see that at every 1 second, the active power and voltage will be exchanged between transmission and distribution simulators. And every half second, the system dynamic matrix like the frequency deviation and the A signal will be sent out to the control center, and the control center will calculate the HT signal and send out the HT signal to the completion generator and the DER aggregators. And then this DER aggregator will allocate the HT signal to individual DER. We simulate this like a dynamic response, and we utilize the Helix filter function to mimic the communication delay or packet drop or this DER's communication HT signals. Next slide. Right.
Sorry, there you go.
I think I have a lot. Yeah, this one. So after we build this co-simulation model, we test our model in a very large scale transmission and distribution networks. Shown in this figure, we use the Texas T&D networks. The 2,000 watt transmission network is utilized for the transmission system, and we fully model the distribution feeders in the Austin area. Within that area, it has about 1 million distribution buses, and we add a lot of additional DER in that region, distributed PV, electric vehicles, and we simulate the system response after we enable this DER to provide frequency regulation. Our transmission contingency is simulated, and we simulate the transmission system frequency response and distribution networks 40 response following the contingency. It shows that this platform is very scalable and efficient to simulate the large-scale transmission and distribution network. In the current co-simulation, we only modeled the one city like Austin area with full distribution feeders. But in our next step, we want to model what the major cities in Texas area with detailed distribution feeders and leverage the existing synthetic data sets they have developed in the Smart BS project. they have a lot of like design feeders for different like cities in Texas area. And in the next step, we will model much more city and with design feeders. And we also in the next step will simulate a lot of like communication variation or failures in our code simulation to study the impact of communication delay or failures of HDR providing HC response. Okay, I think that's most of my like presentation in this work.
Excellent. I see a couple of these look like they're videos. Should I push play on which one first?
Yeah, that frequency one should. I think other one should be okay. Just show the like system response following the conveniency, transmission level response and distribution level response.
Very cool.
Okay.
Awesome. Yeah, thanks so much. Looks like Craig's got a question. I'll quickly see if anybody else has a question, since I know you've had a chance to ask a couple. Not hearing any. Go ahead, Craig. And certainly, if people have thoughts or questions, in addition to raising your hand, you can also put them in chat if that feels more comfortable. So go for it, Craig.
I applaud your deferring to other people if they raise their hand, because I talk too much. But I love this project, but I'm interested. My view is that the grid of the future is not going to be managed through an optimization problem. It's going to be managed through a hierarchical control theoretic approach, because you never have synchronous data. You know, there's so many points to measure, and those points are not contemporaneous. Yeah. So inherently, there's error in every control calculation you make. So there needs to be a feedback loop. How do you see your approach and code evolving into something that can be used for real-time control?
Yeah, that's a very good question. As I mentioned, right now, all the control signals, we consider the control signals in our simulation. And in our simulation, we consider the communication delay or variation or packet drop or information loss. And that information can be asynchronized, as you mentioned. So in our HELICS simulation, we will study what the use case under this like asynchronized information exchange between transmission and distribution and between all different distribution feeders, because in our simulation, we model over 200 distribution feeders, and that information exchange can be asynchronized, as you mentioned.
How long does it take you to solve?
For this, like this large system, we use Unreal's HPC to perform the simulation. Right now, for about 300-second simulation, it took about 15 minutes. If I remember it correctly. It's still okay, but because this system is very large. So.
Well, I don't think it's very large. It's large, but I think we're going to ultimately be solving much, much larger systems.
Yeah.
And 300 seconds is enough yet. So keep going.
Most of the computation takes by the transmission dynamic simulation. This is a 2000 bus transmission network and has several hundred generators. So that dynamic simulation is very slow right now. Maybe in the next step, we want to find some way to expedite that dynamic simulation for this transmission network.
What about dividing into multiple problems, approximating solution for each one on a continuous basis, and then reintegrate?
Yeah, that's a good suggestion. So right now, we want to model this like a Texas system as a whole, as a one like balanced area to study the HC response. But definitely we can separate the transmission network into several subregions and perform simulation for subregions separately. That maybe can like expedite the simulation.
Yeah, I can see it.
Awesome. Yeah, this is a great conversation, and just for the sake of time, I want to go ahead and move on. Again, thanks, Shin, and thanks, Craig, for the engaging conversation. Certainly, part of the reason we've tried to encourage people to have their email contacts here on the slides is a chance to have an easier way to follow up later. So, did I just see someone come on with their video? Well, we'll move on to the next scheduled thing is Yuan. I kind of felt like I might have seen Andy there joining. So if it is you, Andy, send a message in chat and we can coordinate a time to slip you in. But for now, let's continue with our schedule with Yuan.
Hey, everyone, this is Yuan. So today I'm going to present two projects. And so maybe next slide, please. Yeah. So the first project was sponsored by the PNL's LDRD initiatives. And in this project, we actually constructed a transmission and distribution co-simulation platform that can support more than 10,000 inverters. So we leverage the DOE-funded open source tools, GridLabD, Helix, and GridPack. So we actually interconnected GridPack and GridLabD through Helix. And so in this system, we have like 19 distributing feeders and more than 10,000 IPRs, and the total number of loads is more than 160,000. So we can actually simulate the up to 100% penetration of IPRs with a mixed grid forming and grid following inverters. So in the second project was sponsored by is sponsored by CITO right now. It's ongoing project, and as part of the task, actually we tried to collect the PSCAD and GridLabD through Helix, and in this study we will realize the EMT and the phasor co-simulation for distribution systems, and also we want to study the impacts of high IBR penetrations. So next slide. So this is the first project. Actually, you can see that we use the mini WAC system, and the mini WAC system has 120 buses, and we replaced all the 19 node buses by the IEEE 8500 load test feeders, and in each feeder we have 550 IBRs, and the grid forming and grid following inverters are half and half. So in this study, we actually leverage the PNL's clusters of servers, and we simulate the co-simulation. And so we actually did a bunch of studies, and we discovered that as we increase the if we increase the grid following penetrations, and we can see that the frequency ladders are lower and lower, and finally it will go unstable. But if we increase the grid forming penetrations, and we can see that the frequency ladder becomes better. And when once we have like for example, we can simulate 100% IBR penetrations, but if in this 100%, if we have around 12% grid forming, then we will have a pretty good frequency response. So this is what we discovered from the co-simulation. Yeah, and the next slide. So this is actually the second project we are working on right now. So in this project, we want to use Helix to collect PSCAD and the GridLabD. So in PSCAD, we have like the grid forming and grid following inverters modeled, and in GridLabD, we are testing the kind of very simple two-bus system, and we will move on to the IEEE 34 node test system. So this is the first time ever that we have seen that the EMT and the three-phase phasor domain simulation tools are actually connected with each other. So we will probably investigate the interface techniques and some dynamic responses with high penetrations of IBRs. So this is still ongoing, and hopefully in the future we can probably like present more results. So this is actually a CITO project, like a 3-year CITO project, and this we will use the Helix and to do this. So I think that's all of my presentation. Yeah.
Great, thanks so much, and nice job being on time as well. I'll pause here to see if there's any questions from the audience. Okay, I see you still have your hand up, so I'm curious if you have if that's left from before or if that's
a legacy.
a new question.
I put it down.
Okay, fair enough.
Sorry.
Okay, well, I actually had just a sort of question or comment on some of the, just curious what you may have found in terms of the interfaces between the EMT and the phaser, and I know there can be some challenges there. And I think one specific question is whether there's been any opportunities to leverage some of the real-time work that I know folks have done that also cross those that bridge. Not necessarily because you're running in real time, but just some of the interfacing challenges, sort of how they compare.
So, what do you mean by real time? Like the
like for hardware simulation work, for example.
Oh, for hardware simulation, and because in this one we don't have any hardware simulation, so we just like these two softwares are connected with each other. So we actually use the Helix factories to kind of implement that. Yeah, and for the interfaces, actually we are now using the FFT to convert from the EMT to the phaser values. Yeah.
Oh, cool, excellent. I think Otto had a hand up. Did you have a quick question as well?
I had the same question, which is why I put my hand down.
Fair enough. Very fun. Yeah, no, it might be fun to follow up afterwards. It'd be interesting to see what you're doing with the FFT, and I know there's been some work in a couple of different spaces there, so it'd be fun to compare notes. I did have a sort of a logistical question. I think I saw Andy Fisher was able to join. Would it make sense for us to quickly sneak in your slides? We may not have time for questions because we used up a little bit of your time, but are you in a position to go ahead and present?
Yes, I am.
Okay, great. Well, let me bring you back at least closer to where that was. There we go. Oh, so we'll let Andy sneak on here, and then we'll catch back up on our schedule afterwards.
Hi, everyone. Andy Fisher. I'm here to kind of talk about the GridAppsD platform. It's a project that came out of the Advanced Research Grid program at the Office of Energy, OE. It's a big team. The primary development team is here at PNNL, but we have developers at NREL as well, and then a couple universities also working on little applications for proof of concept for the platform. Next slide. So it's the main problem that it's trying to address is an industry problem of reducing time and cost to integrate new advanced applications for the advanced distribution management systems of the future for distribution utilities. It's primarily aimed at distribution vendors to develop new applications for utilities to easily adopt onto their systems. So we developed the platform architecture and standard and use common information model standard to separate the data integration aspect of getting these applications to work from the functionality of how they're supposed to work. So it's separating the data aspect from it so that they have a common standard API to interface with the utilities system. The app innovators are able to leverage the data-rich environment model from whether it's the real world or a simulated world. So the platform needs to be able to provide an accurate simulated model of the real world, model that a distribution system. So that's where Helix comes in into the play. So if you go to the next slide, the two boxes down at the bottom, big box at the bottom, you kind of see the simulators on the left, and you have the distribution system on the right. And so those are meant to be interchangeable to the system. From the vendor's point of view, all it cares about is what's coming into that the core services part. So you have all of your applications up at this top layer, and they're just interfacing with the data that's coming in from either the actual SCADA data coming in, or it's the simulated SCADA data coming in. So to the vendor applications, it doesn't really matter. So it's abstracting away the actual SCADA connections and things like that, so that they don't have to deal with that sort of thing. And the managers inside there are the ones that are hooked up to either the real world SCADA and translating that to get the data in the standard SIM format that all the applications are expecting. And then what we have GridXD doing for in terms of Helix is it's creating that simulation for the development and testing of these applications, and for the training of operators on the system. So it's all automating. It's automating our simulation manager is automating the creation of the real world based off of what's housed in the SIM model. So the SIM is the physical representation of the distribution system, and ideally also will contain things on communication network of the system when eventually, so that we can have things like NS3, and we can show you could simulate the communication as well as the physical distribution system. And then what we've done with this application in terms of results is we had a big, I can't remember when, but we had a big user meeting to kind of with a bunch of operators. We invited a bunch of utility operators to come in and use this system that we had, this test system that we kind of had set up with a 9,500 node distribution model, which is based off of, it's an extension of the 8,500 node IEEE test feeder, with several solar and battery and DERs, and they were invited to look at and use our the applications that our partners and people at the lab also worked on, things like VoltVar and fault detection and restoration applications. There was some solar applications, but we wanted to show how well those applications worked on various scenarios, and so we injected communication faults and actual physical faults in the system, and in increasing levels of disaster, and showing how well they hold up, or how they helped the operators handle the system. That's kind of the biggest takeaway or the biggest event we've done with GridAppsD so far. But
Awesome.
yeah,
Awesome. Well, thanks so much, Andy. This is a really exciting project for sure, and it's neat to see these integration in yet a different space. I feel like we've now got two themes for the day. We started with the theme of transportation, and we've had a number of projects that have a bit of a dynamic simulation space. Just for the sake of time, I want to go ahead and kind of keep things moving along, and then we'll have, if we do have some time for questions at the end, and people can also send questions in the chat box too, as makes sense.
Mhm.
So next presentation is coming from ISO New England. I'm super excited to have be able to showcase this work in partnership with the industry, and I hope I pronounced this reasonably close. Ming Gao, I believe, is going to be presenting here, and so take it away.
All right, thank you, Brian. This is Minghua Hong from the ISO New England. The project that I've been working on with in collaboration with the PNNL team, National Grid, and Iowa State is on the transmission distribution co-simulation with Helix. So there has been some prior work done in this area. So ALOC had done some preliminary T&D co-simulation using the ISO New England 39 bus, and I believe there's a IEEE test feeder system. He had done some good work in that. So as we were investigating how we could do co-simulation with TND, so we kind of tapped into the results that ALOC had achieved during his internship at PNNL. So if you could just move on to the next slide, I want to talk about the background of this work, the motivation that led us to find the co-simulation work done at PNNL. So because of the increased DER activities in the New England area, there has been a lot of behind the meter solar PVs integrated into the system. So, and they're also growing very fast. So the current models of system network for any distribution system below 13.8 kV, they're invisible. So we represent them as loads and as dynamic composite loads at best. So we need to reevaluate these load models for both their steady state, quasi-steady state performances, as well as their dynamic performances. We also need to study and develop aggregate models for to evaluate the impact. Oh,
Yep. Sorry,
okay.
just
All right, that's all
my
right.
mouse got confused. No, not trying to rush.
Yeah.
To
To evaluate the impact of large-scale distribution system on bulk power system from both the grid forming and grid following inverters. So currently most of the PV inverters out there in the distribution grid are grid following inverters. They have simplistic control mechanisms in terms of meeting the 1547 standard requirements. And again, this will lead to the next bullet point. So we need to model and analyze the existing legacy inverters. They pretty much follow 1547 2003 standard. So that has these islanding requirements in no voltage regulation and low voltage right through time. So there aren't those requirements yet in the 2003 standard. So we also wanted to evaluate some of the new inverters that potentially conform to the 1547 2018 standard to capture their response to transmission fault. They would have a timeout curve in terms of their response to low voltage conditions. So if you could go to the next slide. So we did some preliminary work. As you can see, we tapped into the effort that had taken place at PNNL. So instead of using the IEEE 39 bus, so our effort was to replace that IEEE 39 bus model, which is a simplistic model, with a PSSE model that's we use for our transmission planning study. That's a entire Eastern interconnection it's a realistic study model. So we were able to do that. So we replaced the IEEE 39 bus, and then we also in this case used the IEEE 123 node distribution system with 5 grid forming inverters that serves about 40% of the distribution system load. So this work Wei do at PNNL. So he has provided us with some really good converter models for us to test with. So we did the co-simulation. As you can see the picture down to the left, I cannot share with you where exactly that distribution bus, transmission substation bus that we used to connect the 123 node model with, but essentially there is a local generator there. And the secondary side of the transformer was a 2.4 kV that matches with the 123 node distribution system model. So we did the co-simulation there, and we saw results as we expected. So without but time flies really quick. So let me just really speed up. So the results were as expected. So if we had just modeled the downstream distribution system with plain loads, it's a very flat simulation results. But then again, with the dynamics coming in from these great forming inverters, we see the dynamic responses from the distribution system, where you can see that when the voltage dropped below some levels, so this case will be high impedance, three-phase high impedance fault on the substation bus. If you could, yeah. So we can see that, yeah. We can see that all these grid forming inverters collectively respond to that low voltage and try to dump out as much reactive power as possible, which increases their current output. And that's all seen in this co-simulation because this is a relatively simple case. So if the distribution system at large would have had these grid forming inverters, I think we would be able to see the impact on the transmission system. So that's what we're trying to do now. If you go to the next slide, let me just kind of summarize very quickly. Next slide, please. Yeah, so we're now kind of replacing that 123 bus model with a national grid distribution system model. So they shared with us their SIME disk, some of their SIME disk feeders. So we have worked pretty close in finishing converting, rewriting some of the conversion scripts. So we inherited some of the SIME disk to GridLab-D model conversion script from PNNL, and unfortunately that script doesn't work directly with the national grid distribution system. So I had to make substantial modifications to make it work. So we're close in terms of getting the model converted, the dynamic model converted. So once we have that, we would be able to co-simulate the Eastern interconnection with the national grid, at least one feeder to begin with. It seems like they provided us with more data. So if at some point we could simulate a bunch of feeders, we definitely will be able to observe phenomena that we're interested in investigating. So to wrap up, I think the Helix is a really good platform enabling us to perform T&D co-simulation. I think the best part of this is there's good ongoing support from the national labs. PNNL has staff that actively support Helix, and also the ability for Helix to support commercial tools such as PSSC is essential. So ultimately, we wanted to leverage Helix in simulating large-scale system with tools that have been benchmarked for industry application. And then again, the ongoing effort at PNNL to support GridLab-D in terms of modeling new inverter systems like grid forming and maybe upcoming features, control features in the converters, because this work on implementing these new control features of the inverters for GridLab-D has been ongoing at PNNL. So Wei Du has done a lot of good work in this area. So so these aspects make Helix, GridLab-D, commercial tools like PSSE just really fit for accomplishing the objectives of for our co-simulation interest at the ISO New England. Thank you, PNL for your support, and a lot of great staff at PNL who supported our work, and it's been a pleasure. Thank you. Yeah, that's the end of my presentation.
Thanks. Yeah, it's definitely some exciting work, and I'm not sure if you're able to join, but I know there's also been some work, if you haven't already been able to take advantage of it, working with both SIME and PSSE that we'll be showcasing as part of the use cases within the Helix project tomorrow too. So you might be able to find some synergies there.
So let me follow up. So so Helix is able to integrate SIME?
Yeah, they're actually on the phone. Otto has developed a Python interface that does that, and he's going to be talking about it as one of our use cases. He also has a PSSE interface. There are other ways to do it, but that's one place to start that could be of interest.
That's exciting to know. But I think the thing that could be missing is some of these new inverter models that may not be available in SIME. So you could do some dynamic simulation probably. But if you want to study grid forming inverters or grid following inverters, not sure how far ahead SIME or Eaton has followed up in those developments. But the work has been done for GridLab D, that kind of helps us to be able to stay ahead.
Yeah, fair enough. Excellent.
Yep.
Seems like lots of great exciting work too, and definitely it's the more tools in the mix, the more fun, and I think also because it can start to address, as you highlight, these different industry projects, problems and challenges. And so yeah, super excited to hear the work you guys have been working on, and looking forward to hearing more updates. I just doubly checking the time. I think we're a little bit behind, so I want to save any questions to the end. That we do have a little time allotted there, and so we'll go ahead and move on to our next presenter. I believe this may be Daniel, but it may be Marte. I'm not quite sure how to pronounce your name. Sorry. Yes.
Yeah, hi. So yeah, this is Marta. It's the French for
Marta.
Marta.
Okay.
Yeah. Thanks. So well, thank you for just providing us the 5 minutes. It's really appreciated. So I'm just going to go quickly with the presentation and leave the spot for my colleagues Danielle and Rawad. So we work in cybersecurity at the Hydro-Quebec Research Institute. We can go to the next slide, please. So basically, we ended up in co-simulation because it was a requirement for cybersecurity analysis. So we're looking at analyzing the security of the power grid, starting from generation to transmission to distribution, including systems that are deployed at the consumer's premises. So it's a huge system with many components that have different vulnerabilities, and it's been characterized by an invasive deployment of IT technologies in operational environments. So basically, our approach for cybersecurity analysis requires us to have the means to simulate attacks and analyze their impact, develop monitoring and intrusion detection methods, as well as mitigation and prevention means. And we ended up with co-simulation because it's a tool that, first of all, that allows us to model the IT-OT conversion. So it's the coexistence of communication networks with power systems, including the control and the automation processes. So it was the best experimental environment to model cyber attacks and analyze their impacts, to generate data coming from IT and OT sources, and also to assess the robustness of whatever we develop in terms of detection and mitigation. I'll leave it to my colleague to talk more about the co-simulation platform.
Thank you, Mark. Next slide, please. So for the co-simulation maybe the slide, the previous one.
Oh, sorry.
Yeah. So for the co-simulation platform, a part of the work that has been done and was concentrated on the electrical part was to co-simulate 3 areas: electrical, telecommunications, and automation. And at Hydro-Quebec right now, we are using the ISL in System Lab middleware developed by eSIM Solutions, but we're planning, we're open to integrating Helix in the future. So in this proof of concept, we tried to simulate an automation system, which is the power production rejection and load shedding, as you can see in this green rectangle. The ISL is a FMI HLA compatible, we're trying to, in this part of the work, we're trying to focus on the electrical aspect. So we have EMTP connected to with HyperSim and possibly PSSE. We also have real relays that we're using. So we're also using HIL, hardware in the loop. For us, the telecommunications part is only to model the telecommunications network that we can, and it serves as a platform for the applications such as cybersecurity. So I'll leave the next slide for Daniel. Thank you.
Hello, so next slide, please. Yes, so another co-simulation platform that we use for our cybersecurity project was based on Mexaico, and we integrated NS3 with EMTP and MATLAB Simulink, and as you can see in the figure, in the left figure. So technically, in this closed loop scheme, we look for a substation controller to manage the voltage corrections that we have in the power system. But because of the fast data injection, the central controller make erroneous decisions, so send incorrect commands, so we lost the service of the DERs. And you can see some of the references of our recent publications, mostly using the co-simulation platforms that we have in the lab. And next slide, please. And currently, we start to use Helix as a new co-simulation platform, at least in our lab. So we are almost new in this project. So we mainly want to integrate transmission simulator, which is HyperSim, with a distribution grid simulator, SimDis. So we want to simulate a large-scale EV infrastructure, including with the communication system, the loads, distribution grid, and transmission grid, and see the impacts on each side. So that's the aim of this project. So we put some of the components of EV ecosystem on the right, as you can see, and the architecture that we look to achieve is in the left side. So far, we were able to integrate the broker with one of the SimDis instances, and we want to improve the applications. Thank you.
Fantastic. Yeah, this is great to see all of you. Very happy that we came together and we had a little bit of a last minute file exchange, but yeah, this is fantastic. Really, really interesting stuff. And I know one thing that we would love to hear from you, now or later as things go, is not only how things are going, but also kind of comparisons between your experiences, since you have been doing this with a couple of different co-simulation platforms. But we do have a minute or two for a few questions, if anybody has any for the Hydro-Quebec team. Let's see one. Oh, from Ken or Kenneth.
Yeah, hello. I was curious if you're, for this co-simulation, are you using HyperSim in real time on a target, or are you using it offline?
So I will answer. So we're using HyperSim real time and offline. When we're using HyperSim in offline mode, localhost mode, we're basically using the middleware ISL, and in real time, we're only using like the Goose messages and the SV messages, which are a part of the IEC 61850 protocol as a basis for the telecommunications.
Okay, thank you.
Fantastic. Any other questions from folks? Excellent. Well, certainly looking forward to some of the conversation later, and yeah, very excited to see the work you guys are doing. And yeah, it'd be fun to see how this all comes together. Looking forward to future updates. Our next presenter is Jing from INRAL. Sorry, I can't spell my own lab's name. Sorry about that. Jing, go ahead. And I know you've got a couple of different projects you're highlighting here.
Okay, thanks, Brian. Hello, everyone. My name is Jing Wang. In this talk, I will talk about my experience for using Helix to do the DERMS performance evaluation. Basically, we will evaluate a software controller, hardware controller, and also DER power device hardware in the loop evaluation. So this is a talk including multiple projects. I will start from the list of projects that I led and implemented using Helix. So as you can see, this slide shows 6 projects. The mother project is a Holy Cross high impact project. So this is the first project we use Helix, and this project also built the foundation of all the ADMS projects that we have in Unreal. So for this project, we evaluate the DERMS, distributed energy resource management system, embedded in commercial platform, and this controller need to correlate with commercial ADMS as well. So this is the validation purpose. In the beginning, we have all the simulation and the control agents implemented in Helix. We have OpenDSS, OPAR agents, control agents, and the ADMS agent, and the inverters as well. But later, the final stage, excuse me, sorry. In the end of stage, we only keep the OpenDSS and the OPAR agent for simulation, and we have a bunch of hardware system to be tested. So this is a mother project we developed. And down the road, we have multiple CETO funded projects, including EcoIdea, Go Solar, and Energize Solar Expert. This 3 projects is to evaluate the DERMS performance for the DER measurement, and also for the legacy device, grid device controls. So it's the DERMS is equivalent as the DERMS and the ADMS for these 3 projects. And as you can see, they are quite similar. And we have actually the DERMS control agent run in software, not in the hardware. So you can see for agents, we have OpenDSS, OPRT, DERMS correlator, and the load controllers. We have other communication agents as well. In particularly for Go Solar and the Solar Expert, we have 90 hardware inverter to be dispatched by the DERMS controller. And then the DERMS controller is implemented in software in the Helix as agent. So this is a highlight of the great use of Helix for the hardware controller testing. And we have also CETO, Assister, Aurora, and also TCA project. These are ongoing projects. The Assister project, we evaluate the peer-to-peer distributed controls for the subtransmission system control and operation. So we have the control agents run in software in Helix as well. We also have BigBone board as hardware to be tested to communicate with the simulated software controller in OpenDSS in the Helix. Lastly, we have TCA project. This project is to advance the DERMS control for commercialization. In this project, we particularly using the Helix functionality to test the communication impact on the DERMS performance. And we want to see what is the communication boundary for the to keep a good performance of DERMS. And with this upper boundary, the most maximum delay and the possible maximum the packet loss, then we can advise our industry to see what sort of cheap communication they can provide to make the DERMS works. So overall, all this project is to validate the real-time control of DERMS microcontrollers ADMS for DER management. And we really benefit using Helix. So the next slide will show you how we achieve this and make all this project works. As I mentioned, the HC high impact project is a mother project. After that project, we made a generic and a plug-play structure. As you can see here on the left dashboard, these are the Helix agents. We have OpenDSS run either sub-transmission or distribution system. Then we have OPRT agent to interface OPRT. OPRT can do real-time control, control the DI inverter or control legacy controller like K-band controller. It also interface with ADMS server for control or communication purpose. And we have also DERMS control is a controller agent, and then COMS agent to allow the DERMS agent dispatch inverter using standard industry protocol like a Modbus TCP/IP, DMP3, and also SSH protocol as well. Since we have this generic and the plug and play structure, we are able to for the following project, we based on the project needs, we will create a recipe without wasting too much time doing from scratch. So this is a great advantage of using Helix for many different projects. And the next slide will show you one example of using this generic structure. So again, this is a Go Solar project funded by CETO, and Brian Palomir is a co-PI of this project. So this project overall objective is to test the GoSolar is a control algorithm to dispatch the faster response DER inverters and also slow response legacy devices like K-band controllers. We have all this K-band controller and hardware as inverter, as hardware. So how do we test those hardware devices? So what we do is we have OpenRT to interface with these hardware devices, and then we have OPA agent, OpenDSS agent, and for the control we have state estimation and the woman agent. Those are the two key functions of the GoSolar platform to allow women to be able to control the 90 DR inverters. We have the Modbus agent as well, as you can see from here. So this is the overall structure of Helix that using the generic platform. And we, because of the time, I will not go through details, but you can see the signal flow between inside Helix agents and also between software and hardware, and also the time step of each agent in the Helix. This is a great example of how Helix can be used to do the software controller, hardware controller, and power device testing. And finally, I want to share with you my takeaways. Next slide, please. My takeaway or key learnings. So first of all, I think Helix is a really cool tool to integrate and synchronize all the software and the hardware pieces together. It can do real time, make the simulation model run real time, control run real time, and control dispatch the devices, inverter or legacy devices with industry standard protocols. So this all makes Helix as a tool that create a realistic lab testing conditions to mimic the real world application and deployment. Real-time simulation model, standard communication protocol, and the real-time measurement and the command. So this is a great tool to test the real-time control. But based on my experience, there are a few highlights of limitation of using Helix. For example, it uses serial commutation, and such as whenever we run the each agent, and we also need to do the data exchange, subscription, and publishing. Those data exchange has to have some time delay before the when each agent runs. So this somehow adds some delays into the system. So this is one of the limitation I see. Another limitation I see is it is very hard to synchronize the quasi-state simulation like OpenDSS with EMT simulation like a PS card. For the like a EMT simulation study, like grid form inverter stability study, we did that with OpenRT, but with OpenRT coding with Helix using UDP communication that is has some large delay compared to the EMT simulation with time step like 50 microseconds, and so the delay is really not negligible for this type of simulation. And I see another person presented the Helix has integrated the PS card and with GridLabD together. I'm really interested to see how they can solve the problem of the delays and to make it really the EMT simulation with small time step, and also how they can make this simulation in real time. So these are the interesting things I want to learn from others. And again, I think Helix really has a lot of advantages. Real-time control, modeling, simulation, and plug and play, really easy to deploy for the next project. And with the latest version of Helix, easy to debugging and straightforward for implementation. So I really I have the chance to use Helix to do so many awesome projects and deliver good projects to the OE and customers. Thank you. Yeah.
Thanks so much, Jing. Yeah, definitely a lot of very exciting projects. And for the sake of time, I think we might go ahead and hold any questions for the panel at the end, so we can get in our last presenter and then have a chance to have that bigger discussion. But yeah, lots of great work, and I think you highlight some of these great synergies. I hope that you're able to connect with the Hydro-Quebec folks and others who are doing work in the HIL space, because it seems like there's some really good synergies to learn from each other, which is definitely one of the key goals of our meeting. Great. So the last project that we have sort of officially on the schedule, although I did say we have a little time at the end in case people want to step in, is coming from Nathan at Livermore. I'll take it away.
Hi, thank you. So today I'm just presenting on our project that we have for collaborative autonomy with Helix-enabled hardware-in-the-loop simulation. And in this project, we're providing a scenario where we could provide a cyber attack against some power distribution grids, and then making use of GridLabD as simulation software and Helix to help tie that all in together. Next slide. So the general idea here is that we have a set of distributed energy resources. An operator or an adversary might send a control to some set of these DERs. These devices don't necessarily have a set of verification normally. So they'll just take commands, whether those are malicious or they're just normal benign commands, and process them, and hopefully they don't do anything bad. So we propose a way to put almost like a kind of a middleman in between something that's sending a command to the distributed energy resource and the distributed energy resource itself. Neither one will know that this object or this agent is in the way, and then make use of collaborative autonomy to have multiples of these agents be able to collaborate with one another to understand really what is normal and what actually discerns an adversary versus just a proper benign command that's supposed to be operated on. We make use of GridLabD to run the simulation of about 600 inverters in just use within this GridLabD scenario, and we use Helix to help us tie in some actual hardware systems, such as a National Instruments signal generator, which then uses some amplifiers to generate some voltages to a SEL 700G, which then is able to it's a relay, and we can get some of the values off of that line and then use those inside the simulation, and so that it seems like we're actually talking to a real meter, because we are, but in this way we're not depending on any simulated meter. We're actually able to use hardware in the loop here. And actually, if you go to the next slide here,
working on it, there it goes.
Yep. Next slide. I already talked about this. Sorry. And then just hit it a few times until it's at the very end. Yeah, there we go. Okay, so we have these Raspberry Pis, and some of you might be familiar with this, but for those of you that aren't, Raspberry Pis are a very inexpensive microcontroller, or kind of expensive nowadays because of the chip shortage, but we're using these small little devices to kind of act as our agents that are going to be our verifier agents between an RTAC and a distributed energy resource. We then can run the simulation on a laptop that has GridLabD running on it, as well as a Helix broker. And then with using Helix, put a federate on our National Instruments controller, as well as any type of plot diagram that we want to use to visualize some of what's going on inside the simulation, and share the voltages across all of those different federates. Making use of those voltages, we can then control what type of voltage that the meter is seeing, which then these verifier agents and an RTAC might read off of the SCL device to then properly use and send back to the simulation to either verify different commands or verify different things that it's receiving that are supposed to be sent to the distributed energy resource, and either reject or accept those commands as they pass through. This is actually really nice, because then we can we can see exactly what's going on between each inverter. We can fine tune and control what types of voltages are happening throughout a simulated day. This simulation takes over, so it is an entire day. It usually takes about 5 minutes or so for that to actually run through the entire day. We can, even though this is using hardware in the loop, we can still use not exactly 100% real time, and actually move stepwise through and have proper, have some really good simulations, I guess, without needing to depend on waiting an entire day, which is really nice. I'll go to the next slide. And so we're actually able to take whatever results that we get from this model and kind kind of take that to the next level and expand upon whatever our current GridLab model is and verify that with results that we get from our hardware in the loop simulation. It's really nice because, if we have a small little bit of deltas or a little bit of inconsistencies in our current model, we can adjust that in the current GridLab model and then use that within our simulation. Some benefits and some really cool things that we've gotten out of the collaborative autonomy is actually having agents which can die or stay alive, at will. And so when something does happen or something does get killed, the system is still self-healing, and if the agent was to come back, it would still be able to operate as functionally and as normal as possible. Go ahead, and I believe might have been my last slide, but next slide. Yeah, that was my last slide. Cool. So I know that was a little rushed, but if there's any questions, I don't know if we have time for that. Feel free to ask if I didn't explain something completely.
Yeah, we have a couple minutes for questions. Cool. I see Craig's got his hand up.
All right. What protocols are you using within the network?
Within the network, we're using Modbus TCP. This is primarily, so actually, I take that back. So between the collaborative agents, we are using a protobuf communication over TCP, which is using a library called Captain Proto. And that's to go through where we're using a custom library called Skynet that we created that uses that protocol. And then between the RTAC or any of the collaborative agents and a meter, we're using Modbus TCP to communicate that way. And then for between Fedor to Helix broker, we're just using the ZMQ core type.
That's not exactly what you would see in a commercial installation at a substation.
Okay.
I would see more DMP3 61850.
Okay. I mean, so yeah, it's not something that we've necessarily tested with. So I guess the way I look at it from a system standpoint, the protocol that goes between whatever devices we're looking at to read off of, say, a meter, whether it is like DNP3 BACnet or Modbus, I feel like that part would be interchangeable. But I might be wrong here at this. But that's, at least to me, seems like it should be ubiquitous across that. Would I be wrong to say that?
No, I don't think so. I think you're on track. I just I developed a technology with my colleagues, and I did it called Essence. Oh, I'm sorry, that's not an Essence cup. This is an Essence cup. Okay, right there. And I would like to attach my Essence monitoring system to your network because we do some very high resolution monitoring and anomaly detection using AI algorithms. But we don't process Modbus routinely. We tend to concentrate on DMP3 and a few others. But it's just details we can work out. Good. Thank you.
Thanks. And Greg, I think you're aware of this, but tomorrow is one of the use cases within the Helix Plus project. We do have inner ECA involved with Essence and related work going on with Helix too. So it'll be fun to see how things go at that point.
Well, I think there's definitely synergy with this project.
Yeah.
And I'm very interested in doing it. So I'll be sure to be drinking out of my Essence cup tomorrow instead of my Route 66. Good.
It seems like the coffee tastes better out of that one anyway.
Oh, absolutely. It's not even fun. Thanks, everyone.
Fantastic. Awesome. Well, so the next thing on our agenda, we have sort of a couple minutes to see if there's basically anybody in the audience who is working with Helix in their work and didn't get a chance to go. Kind of call for last minute additions or connection points people wanted to make with any project highlights that folks might have. I see a hand up. Let's see. Alok?
Yeah. Hi everyone again. So I just wanted to wear on the Iowa State University hat. So I just finished my PhD last semester and joined PNNL. So back at the university, we also used Helix extensively for T&D co-simulation and actually used it for another use case to generate synthetic measurement data that was used for as an input to various data analytic algorithms. And this was also a DOE funded effort where we developed some data streaming modules where we used the co-simulation output as the input to this, and we could generate streaming data with actual timestamps to generate synthetic micro PMU and PMU and PMU measurements. And Helix was an integral part of that co-simulation output generation. So we were able to generate synthetic data using realistic grid models for various timescales, including some SCADA data and also PMU, micro PMU level high fidelity data with embedding, synthetic noise onto it to actually test the robustness of the various data analytic algorithms. I do not have any slides to talk about it, but I have a couple of papers on the framework itself. I'll just drop them in the chat. So yeah, interested people can take a look. Thanks.
Fantastic. Yeah, that sounds great. It actually.
And I would also like to take this opportunity to give a shout out to Deepak Krishnamurthy, who helped us a lot while setting up that framework at Iowa State during 2019 and early parts of 2020. So thanks Helix team.
Awesome. Yeah, thanks so much. Thanks for that highlight. That's great. It actually reminds me of I know there's also some ongoing work in the CEDO space where a number of labs, PNL, INREL, and others are involved that has a little bit of a space looking on the distribution side with some of that synthetic data. So some interesting opportunities that we may be able to hear about in our next user group meeting. I also saw that Jing, it looks like you had your hand up.
Yes, I just want to use this last minute opportunity to mention another project that I play as an advisory role. I didn't lead that project. So that's ADMS use case 6. So as you know, I have in charge a lot of project using Helix for the terms microcontroller and ADMS evaluation. So this one, but those projects are mainly focused on distribution. So ADMS use case 6, we focus on this TND. So we have transmission and the distribution simulation, co-simulation through Helix. We have also distribution control using the GoSolar algorithm, and that is implemented in GridAppsD. And we have also the transmission RTAG is another distribution controller. It's like the ADMS, but for transmission EMS. And so we have this project for the use case 6. And the purpose, the application we want to evaluate is AGC frequency response and see how the transmission and the distribution system can correlate together to respond to frequency events. So this is another very real world application we have. We have the industry partner and the utilities as well for this use case. So that's expand our capabilities from just focus on D, but also TND control and operation. Yeah.
Fantastic. Yeah. Thanks folks for those highlights. Looks like, yep, I think we're there. I know also one of our other colleagues in this transportation and grid co-simulation space, well, it's unclear exactly who is potentially going to speak, but there is the VTO funded recharge project that is looking at grid transportation and controller co-simulation using GoodLabD and the Caldera transportation tool at INL. So it's an INREL, INL, and perhaps some additional partners project that for those who are in that space, if you're looking to start a little email chain to connect and compare notes, we can certainly make sure to bring whether it's Shabani or Jesse or Preeti or others in on that project too, if there's interest. Well, so then without, oh, sorry, wrong click. There we go. The sort of last agenda item we have until for the next about 15 minutes we have left, maybe a little bit more, is just a chance to first see if there's any, spend 1 or 2 minutes on any of these kind of panel-wide question answers that may have come up and not been able to answer. But I also wanted to kind of pose both to the panelists or those presenting, as well as to everybody here, a couple of questions as well. So I'll open it up for some direct questions, and then if they don't naturally come up, we'll spend a few minutes making sure we specifically address these ones that are highlighted here too. Maybe we'll divide this into 3 pieces. So I'll set my little 5-minute timer. First one for the panel-wide, any Q&A lingering, or especially those that kind of cross projects that people want to ask. Daniel.
Thank you, Brian. I want to ask that using Helix, so far I couldn't find any integration with HyperSim. I talked with a couple of your colleagues, and I understood that mostly the integration with the Helix core is is based on the OpalRT RT Lab software, not HyperSim. So I want to know if there is any plan to integrate HyperSim, because HyperSim also is coming with a Python API, so make it easier to integrate with any core. Like this is exactly what we did with another co-simulation platform. So I wonder to know if you consider that, or like it's going to be any kind of plan for future.
Great question. I don't have any direct answers. I don't think it's been specifically on our radar within the Helix team, but I know there's a number of folks on the call here who may have some comments. As you saw, a lot of other folks doing HIL. So other folks on the panel have I see Wei, I'm not sure if that's a response or a later question, but.
Yes, hi, this is Wei from PNL. Just let you know that internally we have some LDRD project that we are using HyperSim now for some microgrid study, and we are also collaborating with OpalRT team. And now we are getting familiar with the Python API now, so but potentially we can also consider to have the Helix there to do some type of co-simulation. Just but it's not, yeah, but no, we are using HyperSim now, just let you know that.
So it's good that we will probably connect, because then we have some knowledge on the Python HyperSim. So probably can work together to see if we can improve that.
Oh yeah, that would be great. Thank you very much.
Thank you.
Fantastic. I also see Jing raised her hands. I have a sneaking suspicion that there may be a similar HIL point there.
Yeah. So what I want to make a comment on what Wei and just said, that kind of so you definitely can use Python code to integrate HyperSim into Helix, but that is HyperSim is offline. If you want to real time, you have to go through RT Lab and run in the target. That's based on my experience and understanding. Yeah.
HyperSim can run both offline and in real time. If you want to run real time, it needs to be on the target. So for the EMT and the phaser co-simulation, I'm not sure if we can make it on real time. I think it would be interesting to see if we have Helix there. Can we still make it real time for the EMT and phaser co-simulation? But I think if we want to run non-real time co-simulation, that's definitely achievable.
Yeah, long real time offline is straightforward. You just write the Python code to interface the offline model. Yeah.
Yeah, and also there are some different interfacing algorithms, like should we just use a simple FFT or some other method to improve the accuracy? I think this is an area that we should think about. Yeah. Thank you.
Okay.
Awesome. Yeah, thanks. Great question, Daniel. Any other questions folks have, either from the audience to the panel or from all the folks who presented to each other? I think it's great to have the chance.
Maybe Brian, maybe I can ask a question that's maybe a question to your question. I think this is great. I love these exchanges, and I think we find every time that there's people who probably need to get hooked up. Maybe my ask to everybody here: is there a better way to do this than once a year? Is there a way that we can help enable folks to get meeting together on a more regular basis? So anyway, I just thought I'd throw it out there to see if anybody has any ideas on something we could do better in that way.
Jing, did you have a comment? Go ahead.
Yeah, I have a comment. I heard you say Audio is working on integrated SIME into the Helix, right? That will be a great improvement because we receive a lot of SIME model from the utility partners, and we do conversion to OpenDSS, and we spend a lot of time to do model validation. But if we have original SIME model can plug into Helix, that would be great. So my comment is any website or dashboard that you update all these improved or expanded functions or application of Helix? Where can we find this information? Because it's a great tool. There's a lot of potential and possibility there. We want to know what are the new things there. Yeah.
Yeah, go for that. I was going to call on you first. Yep.
Yeah, I do have documentation there in the repo, but also we've publicized this on the NREL external looking website as well. So there is some text there as well that links to the documentation.
Okay.
Well, Otto, are you able to like paste that? I think there's a GitHub site or something. Maybe you could paste that in the chat for folks who might be interested.
Yes, give me a second.
Cool. And I think the other thing I heard there, Jing, which is a good thing for us as a Helix team to note, also is there is a space within our website where we can have maybe there's an opportunity to kind of keep this a little bit more up to date in terms of some of those tools. I know that's something we've worked on in the past, but maybe that's a room for making this a little bit more obvious. So yeah, thanks.
Yeah, thank you.
So another comment here. I'm having trouble getting the names up here. Wei, did you have something else as well?
Yes, I just also want to comment on SIME because we are at PNL, we are running a lot of TND co-simulation to study the system dynamics. So it would be great that SIME can be directly connected to like the Helix. So, but one of my concern is, if we want to study system dynamics, we really need to run dynamic simulation of distribution system. Based on my understanding, SIME now mainly focus on the quasi-static simulation. If we want to enable the dynamic simulation capability of SIME, they need to have different inverter dynamic models. And based on my understanding, SIME not only do the three-phase balanced transient simulation, but with very limited models there. It would be great for SIME to have the motivation to have more dynamic models in the system, because then we can study the dynamics of TND system better. Just one comment. Thank you.
And also coming from the ISO, it's hard to justify in the ISO budget, who's the transmission system operator, to purchase SIME license. So a free GridLab-D with some of the newer models, like the inverter models that Wei developed, was just fit. I mean, budgetary wise and scientifically, everything, it looks good.
Yeah, thank you, Mingo. Fortunately, we have some funding to support us to do the dynamic modeling of distribution system now.
Yeah, keep up that good work.
Thank you.
Yeah, I don't know if you have any comments on. You've been working with SIME, and I know they're maybe a little bit more in the dynamic space, and then
they are
certainly not. Yeah, go ahead.
So when I talk to SIME folks, they do say that most of their customers are on the distribution space, within the transmission space, and they most of the utilities are not interested in dynamics at this point, which is why a lot less investment goes there, right? Which is understandable. I am sure if there is a lot of interest within the customer base, they would definitely invest and build out dynamic models as well. I would add, as part of this effort, we got licenses for 2 different types of simulation modes, which does not include dynamic. So we currently don't support dynamic anyway in SIME, because we don't, at least I don't have the licenses. This is open source. I would definitely say if anybody's interested to extend that, please do. The way the code is structured, as you can go to the GitHub repo and see, all you need to do is extend on the base class, and you can support any new additional simulation mode. And given the restrictions I haven't been able to do so.
And just for sort of completeness in the dynamic simulation space of open source tools for distribution, there is some support within OpenDSS, and I know Adel again has been adding a couple of models into the PyDSS framework that wraps around it. So if you've already got the good libd infrastructure, you're set. But if you're in an OpenDSS world, there's some opportunities to leverage there as well. Cool. Well, we're out of my little time there for our panel-wide Q&A, so I want to make sure to kind of ask these questions back to the panelists and really audience. And I think this could be just kind of a free-form conversation among these last 3 questions that are posed here on the slide. You know, so for folks who are already using Helix, you know, what do you like best? What can we do better? And then, you know, kind of for anybody, again, presumably also those using it, but maybe there's other perspectives too, in terms of like, what would it take for wider spread adoption? And, you know, that could be locally within the research team you're already on, or also if you had any thoughts about, yeah, well, we can do it, but for X reason or another, we really need to change it so that there'll be even broader industry adoption. So any thoughts on that space? Open forum.
I think PNNL's strong support of Helix development, as well as supporting users, helping answer questions. I think that really is outstanding. My personal use of Helix has been such that the interface, all of it takes a little time to digest and put together. So I know there's a better way to improve the user API to make it a little bit more streamlined and easier to use. So yeah.
Awesome, thanks. Yeah, just in general, it's super exciting to see, like, we have the sort of national lab support model going now. You know, sometimes people have direct connections to specific labs. There's also the Gitter channel and other forums that use the office hours, where, you know, the sort of the whole core development team tends to weigh in. I'm just wondering, like, and as you project out in the future, we certainly are hoping to be able to maintain that type of support channel, but maybe some changes are eventually in the DOE funding space. So I wasn't sure if you had any thoughts on, you know, what might be other models to help provide that type of support, and just how critical that is in terms of the industry use.
The industry use, at this point, I think I'm in the R&D team here at ISO New England.
Fair enough.
Yeah. Yep. So there's also a decision in terms of if something really works out here, and then we wanted to use Helix as the platform to support. And I think the National Lab, I mean, I don't have an answer to this question. You would also be looking for a partner to either commercialize it or have, you know, find a venue to provide long-term support with maybe private funding. So I don't have a good answer to that.
Great. Yeah, no, thanks. This question may continue to come up over our next couple of days of this workshop, because we're in the process of trying to brainstorm, and you have some ideas, but are always very excited to hear other people's perspectives and suggestions about what might work or what might not work or things like that. So yeah, thanks. Well, it looks like I see Jing's hand up.
Yeah, so in terms of commercialized Helix, so I have a project working together with Siemens. So they see that's the 5th project I put it in the list of projects in the slides. So that's Aurora project. Siemens is a prime, and we implement all the peer-to-peer control in Helix. They see Helix is a very good tool to test the real-time controls. And so they plan to develop Helix on their end as well. And they are going to commercialize it for many different projects. Yeah, so that's one ad I want to bring. Yeah.
Fantastic. Thanks for sharing.
Brad, one project I know of is the utility data is building out a Helix interface for their tools. So they essentially have this machine learning based model where they're able to ingest SCADA and AMI. They don't have any physics-based model underneath, and they use that to optimize system states. So essentially all the assets within the system. And they're using Helix to do hardware and loop and other things as well, testing out the efficacy of their models.
Fantastic. Great to hear. Any thoughts on, you know, there's a lot of users who are not directly necessarily entwined with the team. Are there sort of closing thoughts on things we can do better to help support you all in your current efforts? Other questions are fair game too. I just figured that we hadn't heard tons of those. Okay, well, maybe if people, we'd actually very excited to hear those kinds of comments. If this is an awkward form, then feel free to send us an email, or there's also the Helix developer list. We're always looking for kind of things, ways to improve. I'm not sure if there's any specific highlights about, oh wow, you know, this is my favorite thing about Helix, or any other kind of comments people had as we wrap up here. Jing, I see your hand up. I think that may be from earlier, but certainly feel free to jump in if you have a comment. Great. Well, I think we're approaching the bottom of the hour, and I believe on our agenda, let me see if I did this right, that should show up next. Oh, nope. I thought I had it, but I forgot. Let's see, I can get there this way. Just next up on our agenda, after a 5-minute break, we do have a usability session, still on the same channel. So I don't know if Jason or Trevor or Deepak, who I know are leading that session, have any closing comments, or if we just reconvene in a couple minutes.
Yeah, no, thanks, Brian. I think we're all good to go here. We'll just take 5 minutes just for everyone to refresh your coffee and do whatever else you need to do. And then we'll jump right into the next session at the bottom of the hour.
Excellent. And thanks again to all our presenters. Fantastic to hear all the great use cases, and thanks for taking the time to share those with us. And certainly encourage you to connect with folks. If you didn't manage to find someone's email or contact when the slide was up, let us know. We can help make those connections happen too. And so thanks again, and we'll see you in a few minutes.
All right, we're at the bottom of the hour here. Before we get started, just make sure Trevor and Deepak, you guys are both online again.
I know I'm here.
I'm here as well.
Excellent. Well, perfect. Thank you, everybody, for sticking through the end of the agenda today. This is actually a really exciting topic area that Trevor and Deepak have been doing a lot of work on with the help from a lot of folks across the team. And so I'm pretty excited to share with all these changes that have happened over the last year. So with that, Trevor, I'll turn it over to you and Deepak to get going.
Great, thank you. Okay, there's my camera catching up. Welcome. Yeah, as Jason kind of introduced, I'm Trevor Hardy at Pacific Northwest National Lab, and Deepak Krishnamurthy over at NREL. We'll both jointly be presenting. I'll be doing most of the talking and slides, and Deepak will get to do what I would say is the fun part, doing some demonstrations of some of the new features and functionalities we've been building in. Deepak and I, as we've been chatting in preparation for this, we think we're going to have lots of time for discussion. So there'll be a mini break for questions, clarifying questions halfway through before we do the demonstrations. And then at the end, we're hoping there'll be a good 15 or 20 minutes time for discussion. So keep that in mind, and let's kind of get going. Oh, let's see if I can get PowerPoint to cooperate for me today. There we go. Okay. So usability. If many of you have been Helix users at one point or another, and depending on your software development background, this getting into Helix can be a complex, difficult thing. Right now that's fundamentally some APIs, and you're gonna have to write some code, and hopefully it's in a language you're familiar with. But if it's not, you've got to get over that hurdle as well. And I say all this to say that Helix usability is kind of front and center for us as a team right now. And yeah, we just recognize that if we want Helix to be broadly adopted, we need to be addressing usability in every way that we can. And I know I'll just speak for myself. I know at a lot of times it feels like our hands are tied in that we can't. There's only so much we can do because Helix is general. It's a platform, right? We don't know what your use case is until you start talking to us about it. So we are always kind of fighting that balance between how do we make this general enough that it can do the things we know people want it to do without being so vague that it's like, well, here's a list of APIs. We hope you have fun using those, right? So what we want to talk about here is the work we've been doing over the life of this project, as well as the recent things. And then, as I mentioned there, the second half, Deepak will be showing off some of the new ways that we're hoping will be helpful for those of you that are getting into Helix or using Helix now. So this is kind of a rundown, and Jason hit many of these before, but I think I wanted to highlight these right now because we have put in a lot of effort to try to be as accessible as we can be. The first kind of front and center in terms of how we want to help users is the documentation that we provide. That is up on the Read the Docs site, helix.readthedocs.org. Excuse me. And in there we have our user guide, which starts out with a tutorial. You can walk through in 5 or 6 different examples, talks about the key features in Helix that you need. What does Helix mean? What is a federate? How do I get these things talking to each other? And then there's a second, much more extensive section where we kind of highlight specific features, the advanced topics we call it. And that's been just continues to grow as we have time and there's an obvious need for an explanation of a new feature. In addition to that, for those who are more on the programming side who are dealing with specific API questions, we have the API reference, which shows for many, probably not quite all of the supported languages, how what the APIs are, what they do, what the arguments are, what they're going to return, kind of classic software development stuff. And then also the configurations options reference. I think we had that mostly put together by the meeting last year. I can't quite remember. That has been that has turned out to be very useful, as it is trying to be a relatively comprehensive, ideally exactly comprehensive list of all the different flags and features and ways you can modify and customize Helix so that it will work for your particular use case. I go to it all the time. It is an incredibly useful resource for if you are trying to understand what can I actually make Helix do for me. On top of that, we have the example suite. There's documentation in the Read the Docs there about each of the examples. It just talks about why we did it, what we're showing off, kind of the the details of the example itself, and then we have the actual code itself. So all these examples, is this true? Yes, this is still true. Right now, all of the examples are written in Python, and they show off, as I mentioned before, kind of specific features. You can download the code. If you've installed Helix, they should run for you. You can use them as starting points in your code. They can, show you how specific APIs are actually working. Pause the debugger, look at the objects that are coming back. We are trying to give you a running start, hopefully, as you're jumping into Helix. Our YouTube channel has a lot of the recordings we've done. A lot of those have been done under the initial Helix funding, but it gives you, again, kind of a way for those who go to YouTube first for their documentation. This is our attempt to kind of show what Helix is about, what it can do, what it can provide. And then we have one up now and more are on the way, but we've started doing screencasts of various things in Helix. So the first one up is how do you install Helix? And it's a 30-minute video showing 4 or 5 different ways you can install Helix and how to manage Helix and all of that kind of stuff. Other ways, if you're looking for specific support, we've got the discussion forums up on GitHub. There's a discussion tab at the top there, and those, everybody is seeing those. By everybody, I mean the development team. The Gitter channel, similarly, is a real-time chat. Again, all the development team is on there. It's a good way. The screenshot I captured was just from this morning. I feel like probably at least once a week, probably more often than that, we have new users jumping on and asking questions. So it's also kind of an archive of what we've discussed in the past. And then we have bi-weekly office hours, an hour set aside where you can just join in and get actual support from the developers directly, ask them the questions that are hard to type in on Gitter. So in terms of what we've been doing recently, we've had a few extensions of the documentation that we think would be most helpful. One, iteration. We have an example up now that shows you how to use the iteration APIs between models. We are using the same kind of EV charge management example that all of our examples are using. We've changed the battery model so that the need for iteration is a little bit more apparent. The graph there is showing just how we get convergence across those 5 EVs so that you have a consistent state between the charger and the electric vehicle itself. I am personally super happy that this is up there. I feel like every time I present EV, particularly to computer science people or math people, the first question is, what about iteration? How do you converge the models and make sure they're at a consistent state? And I have to always say, Helix does that, and it's I have to kind of mumble a little bit that, well, you just look at the API reference and you can figure it out. And now we've got an example, and this will make my life presenting on Helix quite a bit better. Tomorrow you'll be hearing more about translators, but there we have an example of that. That's a new feature that is on its way out. So we've got an example in place that will show you how to use that feature as well. And then based on the experience, more than one of our users was dealing with Helix in more complex networking environments, we've added some documentation and an example on how to use Helix when you have to worry about IP addresses and ports and firewalls and all of that kind of stuff. Again, that's a little bit of a general example in the sense that everybody's networking security environment is different. So we hope we're showing you the tools on how to do it, but there's still going to be a little bit of work on applying those tools correctly. Screencasts, I've already mentioned one of those. The installation one is up on YouTube. I've got another one written, yet to be recorded because it relies on translators, but it's showing an example on how to write federates, and I have tried to use all the different inputs and output methods that we have in Helix in one example, and then again, kind of live streaming how to put that together, how you'd actually go through that. And then last but not least, we've been working on Docker images and have a small suite of Dockers that we are making available that have various versions is not the right word, but various language bindings included in them for those who prefer to interact with Helix in that way. So the big kind of topic of discussion today, or that I want to present on, that I think will probably spur the most discussion, is what we call use case standardization. Is kind of a term that I use a lot more. Some people on the team, historically, we've called it the domain API. It's not exactly an API, so that's one reason I'm kind of shying away from that term. But the idea, Jason kind of mentioned this earlier in his introduction, the idea behind this is that in an ideal world, if you want to do, for example, a T&D steady state co-simulation, it would be really great. Like we on the Helix team have a strong understanding of what data needs to be exchanged for that. It's kind of the quintessential use case for Helix, and because of that, there's a strong sense in which, you know, if you have a tool that does power flows, you know, for on the transmission side, and you have another tool that does power flows on the distribution side, then you shouldn't. This should be really easy, right? There should be it should not be difficult and require a lot of effort to get these two tools talking to each other. So that's what we're trying to get at with this use case standardization. The idea here is that if we can, you know, specify and line up the ducks exactly right, you should be able to run a T&D, for example, a T&D steady state co-simulation, and you should be able to use PowerWorld or GridLab-D together, and without changing anything, assuming you've got models and all the appropriate tools, you know, change that out to use PSSE and OpenDSS or MapPower and SimDist. It should, that interface should be standardized. There's no reason that it needs to be fancy. And so that's kind of the driving factor. And the dream is that we do kind of have this one click, to abuse the term, a one-click analysis, right? Like pick out the models for each tool, tell them to use the standardized interface, and hit run, and it does it, right? That is the dream. So this is what we've been working towards for well over a year now. We brought it up at the last user meeting, and we've made significant progress. A lot of this really boils down to we have a document, and it specifies a bunch of things that if you want to support specific use cases, your tools will have to provide the interfaces and work in particular ways. So in some respects, it is a standard document that tools will need to comply with. What we've realized in going through the process of just drafting this quasi standard is that there's a lot of details to get right. We've significantly reworked it multiple times. We've realized, well, this feature can't work this way if we make the specification in this standard. We need to change things. So it is still definitely a work in progress, but we've spent more time working on it. Otto, who spoke during the last session, has most recently been working on just this kind of an example, a T&D steady state, showing how you could use different tools. You know, kind of test driving the standard and seeing, does this actually work the way it is? Another thing we've realized as we've been working with these various tools is every tool kind of has a different software architecture and assumes different levels of interaction and even a kind of extensibility or a controllability via something like an API or a scripting environment or something like that. And because of that, we've realized that integrating and working with this standard is going to look different depending on the kind of tool you have. So we've also been working on, and we won't have a lot of time to show this off, but we've also been working on what we call a standardized implementation, and it is a way that if it makes most sense for your particular tool, you can pick up this code and implement. We basically stub out 3 or 4 different things depending on the use case. 3 or 4 or 5, however many functionalities that the tool needs to provide, and if you are able to, you know, write in code at that point that will integrate with your tool to provide those functionalities, then you can use what we call this standardized implementation even. So that's even one more level of standardization. But what we've realized is not every tool can even support a standardized implementation. Depending on the tool, you're going to need to do that implementation you may have to do it in a different way. So just as for example, the T&D steady state use case that I've been talking about here. So what we've figured out, or the direction we're heading so far with this, is the first abstraction that we've defined is a use case. That is, what we've decided so far is that we cannot define a standardized interface unless we also are simultaneously defining it as a specific use case. And there are downsides to that, but so far it's the best answer that we've been able to come up with. So if you want to do T&D steady state, in this case, we've defined that there's a very simple data exchange that needs to take place. You can see it right there on the screen. If you want to do T&D dynamics, potentially there's a different steady state. If you want to do D plus a CVR controller, then that will almost certainly have a different standardized interface for it. So depending on the use case you want, different interfaces are going to be required from different tools. The upside to that is that it means that there are tools out there that have, almost all tools will support a broader set of features and functionalities than a specific use case defines. And that means that we can use a lot of tools for a lot of different use cases. The flip side of that is if your use case requires that, this is a silly example, maybe on your distribution tool, for some reason it doesn't provide access to the nodal voltages. And if you are trying to do the CVR use case, you might need that, right? That might be in the specification for the standardized use case. If that's the case, then you won't be able to use that tool for that use case because the use case says, you need those voltages. So again, top level abstraction is there is a standardized use case, and that use case says, here's the tools you need, the simulation tools, and the tools have to be able to provide these kinds of data. The next level down to that is, okay, so for each of those the data that needs to be exchanged, what does that mean exactly? So, and that's where this this information you see here on the lower right is specifying in detail what those names should be. So it specifies the name with, in this case, there's a wildcard for that, the global unique identifier. Ideally, that will be something that is related to that parameter in the model. So it could be a bus name, it could be a line name, it could be a controller name, those kinds of things that are going to be unique to that model, but also informative. That's specified what type of data is going to be exchanged, whether the units associated with that, if there's any metadata associated with that. One of the new features we've added, somewhat motivated by the this standardized interface, is tags. So you can associate tags with lots of different entities inside Helix now. That it provides us a way to put metadata as a kind of a sidecar item rather than starting to develop extremely long variable names that contain all the metadata and requiring those to be parsed correctly. So with those standardized interfaces, you can be guaranteed if on switch out my T side, if the next tool coming in is going to use the same standardized interface on the same model, it's going to have the same publication key. It's going to be putting out the same units, and that allows it to be transparent to whatever D-side tool you may be using there. So to provide a little bit of update on where we are in the development on this, the draft standard is nearing completion. Like as I've mentioned, we've redone it enough times that it feels like we're honing in on the right set of information that needs to be specified there. It does, as we've kind of been pushing on this ourselves, we've been realizing, well, that if we want to do it this way and if we want that kind of flexibility, then we're going to need to have new features put in Helix. So some of those are in development right now. Thus, we haven't actually been able to test out what we expect to be the full implementation. And then, as I mentioned before, depending on the tool, we've realized something like a standardized implementation could be very useful and may even be required. So we have that software infrastructure in place there. And that, I think, yeah. So if there are any clarifying questions, if you disagree with things I've said, we'll have plenty of time to discuss that as well. But clarifying questions before we move on to look at the demos. Hey, Andy, go for it.
Hey, Trevor, quick question on the tags. Is that supposed to kind of replace the info field that we typically have been using in our implementations?
No. I'm sorry, I interrupted. Keep talking.
No, that's it.
Yeah. So the info field is not. So we want to keep that is sacred space for the user. So you'll continue to be able to use info in the same way. Tags is we expect it to be more standardized kind of information that is transmitted in tags, though it is arbitrarily definable. I should say it this way: we are using it to transmit standardized information in the standardized interface model that we're putting together. But it can be it's a little bit more diverse in that it can be associated with more items in the Helix, more types of objects in the Helix space than just the info field.
Right. Yeah. So it's not specific to a tool. Basically.
Correct. Correct.
And I think also, I'm not sure if there's a difference in the queryability there. It might be worth.
Yeah, the
Yeah,
info field itself is private to a federate, and all the tags, you can query them from other locations in the federation.
Thanks, Phil. That was Phil Top, one of the Helix developers. You'll be hearing more from him tomorrow. All right, with that, well, like I said, there'll be plenty of times after this for questions. So I'm going to stop sharing and turn it over to Deepak.
Hey everyone, I hope you can see my screen. I'm sharing my screen right now. And
yeah, look.
And I hope the font size is okay. If it's not, let me know and I can increase it. So, like Trevor mentioned, I am going to show a few demonstrations of the work that we've been doing. This is primarily usability of Helix and how we're trying to improve that. Any feedback here would be appreciated, by the way. So the first thing that I wanted to talk about was the Pythonic interface. This has been in work for a long time. And I just wanted to walk through what this looks like and some new features more recently. So I have a file open here in my terminal, and it is a Python file that is a Helix federate. And in this case, I'm using the old Python interface. And the old Python interface essentially mimics the C interface. So as most people here might know, the Helix Helix is a C library or a C++ library that exposes a C interface, and the Python interface wraps the C interface. So all of these functions that you're seeing over here, Helix, federate info, set code name, Helix, federate info, set code type from string, and so on, are all direct mappings, one-to-one mappings to the C interface. So you can use all of these functions in Python, but there is a more Pythonic way to do this now. So you can create a federate info, and then you can do federate info dot core underscore type equal to ZMQ. So this line and this line basically do the same thing. So the Pythonic interface here essentially calls the Python C interface. So there are a number of improvements like this. So I'll just focus this for now. We don't need to look at the old interface. So there's a property-based interface that exists on every object that is created from the Helix create functions. So for example, the federate has a register global publication function, an enter executing mode function. In the old interface that looked like Helix federate register global type publication, and you pass in the object, but now there exists a method on the object itself. Similarly, there is a request time function, request next step function. The other thing that we have now in the Python 3 Helix interface is types. So let's say you did something like request time. If you have autocomplete set up in your code editor, it'll usually show you what the type is of the argument. And if you happen to call the function without passing in an argument, it'll say, that that argument is missing. So there's some additional typing information that we've added to every function that should improve your coding experience if you're developing a federate in Python. Okay, so that is the Python interface. I wanted to show next some of the features that we've been adding to the command line interface. So when you install the Python package for Helix, you get the Python library as well as some of the built-in Helix apps. So for example, Helix _broker is a command line utility that you get when you pip install Helix. But in addition to this, we want to bundle another command line interface. This exists as a separate repo right now, which you can install, but we want to make it as part of the Python interface itself. So that is the Helix Helix CLI, and this exposes a bunch of functions. So this exposes the run, the profile plot, the server, the observer. So I'll walk through some of these commands that are exposed as part of this command line interface. So first things first. Let's say I wanted to run a federation. So I have 3 terminals open over here, 3 splits, and I'm going to run the broker in the first one. And I'm going to say I have 2 federates that I'm going to create as part of this federation. And the first one is a Pi sender, and the second one is a Pi receiver. So this sender basically sends a value, sleeps for about a second, and the receiver receives that value, and there's print statements to show what's going on. So that's like a very simple course simulation. If you did want to run this course simulation with a large number of federates, you'd have to open multiple terminals to do it, and that's not ideal. So there is a Helix run subcommand that takes in a runner.json file, and when you run this, it basically runs the processes in a background process. So in this case, it's running the Pi sender, the Pi receiver, the broker, as well as an observer. So this is all features that have existed for a while, and I'm sure a lot of people are using it. The observer is a new feature, and I want to talk about that today. So first, let's say I wanted to run this without using the runner.json. I could do it like that. So the observer is a command that exists in the Helix CLI. So this is the same thing that I would be doing before, but now I'm going to pass in 3 federates to the broker, and I'm going to run the same Pi sender, the Pi receiver, and I'll run the observer. So again, now the same course simulation is running, but we've passed in an additional federate, which we're calling the observer. And essentially what this observer federate does is it subscribes to every topic that exists in the federation and stores all of that information in a SQLite database. So I passed in a command line argument over here saying database folder and the test folder. So in the test folder, there exists Helix CLI SQLite database file, and this has a bunch of tables inside it. So there's a lot of information here. For example, there's metadata about what Helix version was used, when the file was created, system information about what the operating system is, and the compile flags that were used in Helix, the codes that were available in the Helix library when this was run, and so on. So there's some additional information here that can be used for debugging. And in addition to that, we have built a web interface to extract data from that database file and visualize it. So I will click on this box over here, and in the test folder, there is this Helix CLI SQLite database file that I just created. And if I open that file, I can see that there were 2 cores as part of this core simulation, 2 federates, just 1 publication, and the publication name was global topic, 1 subscription, the source of the subscription and the target of the subscription, and the data, the data that was being exchanged on that topic throughout the core simulation. So in this case, there are just 11 rows because it's just a 10 time step simulation, and the values that were being exchanged are just incrementing over here. Okay, so that's an example of the dashboard part of the web interface. We also have a topology tab, and this shows how your core simulation was connected. So in this case, there's a sender federate that basically is sending data over a topic to the receiver federate. Now, for a single topic between 2 federates, it's not super interesting. So let's say I run this, I run a different example now. This is 3 topics, but again, just between 2 federates. So this will just take about 10 seconds to finish. Okay, so that completed. So now I can go back to this folder. And now there's a SQLite database file over here. I open it, and now you can see some of this has changed. Now there's 3 topics over here, and the table also contains the data that was exchanged on all of those 3 topics. And if I click on the topology, you can see there's 3 different groups on this directed graph. I can disable the labels so that you can see exactly the topics, exactly what topics have been subscribed and published from. Okay, so that's a quick summary of the web interface. We're going to add more features such as visualizing what federates are in your runner.json file and what have been run. So there's more features that we're planning to add as part of different tabs essentially here. So I wanted to show another feature. So I have another example here. Actually, yeah, I have another example here. Let me open this file and show you what the runner.json file looks like. So this is essentially a list that contains the command that you want to execute as part of the exe value in this JSON object. And every JSON object represents one of the processes. So in this case, I have 20 processes. There is a sender and a receiver duplicated 10 times. This takes a few minutes to run, so I have already run this before. And actually, let me open that file again. So in addition to those 20 processes, the 20 different federates, I've passed this argument to the broker, which is the profiler argument. And this creates a profile.txt file in the folder where Helix CLI is running all these processes. And that contains profiling information about the federation. And we have some functionality to plot it. So this hasn't completed yet, so I'm plotting some information that I've already saved. And this is what it kind of looks like. So this is a heat map of how much time all the different federates are spending just waiting or doing some computational work. So you can see all the sender federates, because the sender federates all have sleeps in them, have blocks of color in there. The way I'd programmed this was that the sleep time was proportional to the number of the federate. So federate 1, sender federate 1 sleeps the least, sender federate 10 sleeps the most. So the colors kind of correspond to that. And the receivers basically are don't spend any time. They just wait till they have to receive information from the broker. So they're not doing any computational work. And the sleep time in the sender federates basically represent what computational work you would be doing in your federation. So that's about it from my end. I showed some of the Pythonic API, and I showed the web interface and the current profiling plot. We are planning to make this profiling plot as part of the web interface as well, so you won't have to run anything from the command line. And essentially, the web interface will be your one-stop to using Helix, ideally. So you should be able to run a federate, maybe start, stop, pause, and debug a federate, or after it completes, visualize and do any post-processing analysis using the web interface, as well as get profiling information on there. That's all I have. Are there any questions? Adil, you have a question?
Yeah. So this is really neat work, right? Because a lot of projects, our co-simulations are starting to get bigger and bigger, and when we try to understand what is the bottleneck, I think the diagrams like these could be very, very helpful. The question I have is, how much overhead does the web interface add in terms for large simulation? For a tiny simulation, I'm sure it's not going to be that much.
Yeah, sure. So the observer federate basically subscribes to every topic, and it also receives values from all of those topics, and it could. There's basically no sleeps in there, so it should be as fast as possible. I imagine any computational work you're doing in other federates is going to be more overhead than this. But for very large simulations, you're subscribing to every single topic, and that may cause some overhead. I don't know. We haven't tested that. But I am planning to add in some ability to filter what topics you observe, so then it'll only subscribe to those. And in addition to that, there are some features that, for example, the topology of what publications are connected to what subscriptions, that information can be retrieved after you register all the publications and subscriptions, but before you start the course simulation. So there is some features that I think won't be computationally demanding or cause any bottlenecks.
Makes sense. So would you be able to use tags, for example, in such a scenario, since you use tags to filter things? Would that be a possibility in the future?
Possibly. I haven't.
Eventually, yes. That's not currently possible, though.
The one comment on chat was that a simulation timing diagram would be useful. Would you be able to clarify what you mean by a simulation timing diagram?
Sure, yeah. A diagram that would explain how the federates are interacting in simulation time space would be really helpful to know if additional undesired delays are being added unintentionally and things like that.
Yeah, I think I have that feature. I haven't tested it, so let me check.
Nathan, this is Trevor. Would that be like just showing the dependencies between the federates in terms of timing? Or is it different than that?
I'm kind of imagining just showing every federate when it's acting at at each time step.
So this current plot is showing how much time all the different federates are spending in real time. I have the same plot in simulation time, so that kind of gives you a sense for for a timing diagram. But I think I haven't exposed it as part of the command line interface, so I can try to do that while there are other questions.
Nathan, maybe follow up on that. Are you thinking more like a UML style timing diagram where it shows dependencies between the different simulators and things like that?
I'm not super familiar with the UML stuff.
Oh, yeah. Let me see if I can post a link and we can follow up over chat here.
Sure.
But I imagine you're wanting to be able to see things like what internal time step did simulator A receive a message and things like that, or so that you can get an idea of the actual delay between simulator A sending the data, simulator B using the data, kind of a
Right.
deal.
And is there any time that's being lost that wouldn't exist in the real world? Are we accurately simulating how time will flow in our in the real world?
Right. Yeah, because there is that inherent like one time step difference between simulator, actually using the data. But I think that's a implementation problem rather than something wrong with the Helix API itself.
So this is the plot where it uses simulation time. I just changed the data. I think in this case it's not very interesting because all of the federates subscribe at the same time. So this is a federation that occurs from 0 to time 10. But maybe I can experiment with this and add it as a feature.
So Deepak, if there was a federate that was taking a very long simulated time, would that make the block longer?
I have to experiment to check because I don't know how this works. Because I don't know. I think if you use something like the request time async functions, then you will see some widths over here, maybe.
Yeah, generally, I mean, a lot of federates don't use that function. So generally, even if a federate takes an hour to figure out what it's doing at a time step, in terms of simulation, that is all happening at that one instant. Yeah, we'd have to think about that.
Yeah, one of the things I find is it can be really difficult to explain timing to other people, and if something like that diagram that you showed, which looks pretty good, could be generated automatically, it would not only help the modeler but also help in explaining to other people what's actually happening as well.
I think Brian had a question. He has his hand up.
Yeah, thanks. It was just a comment or I guess question related to the profiling. I think you attached those in your demonstration when you started up the broker. And if that's the case, when you start to get in a multi-broker environment, how does that work? Are you going to end up with duplicates, or is it just going to capture the data that's transiting over that broker, or how would that look?
The profiling is hierarchical, so it will capture wherever you specify the profiling flag, and you can specify that in multiple locations. So if you wanted duplicate data, you could get that. Otherwise, if you wanted all, you just specify it on the broker. If you want it on a specific federate or subset of federates, you can specify that per federate.
So thinking back to the use case, I think that diagram that sticks in my head right now is the one Nadia showed, where there's a master broker and then like a handful of kind of sub brokers. If you put this on the master broker, you get everything. But what would happen if you put them on the sub broker? Would it just be everything that's transiting below that, as well as going up to the master? Okay, yeah. So then you could. There's a scalability. I think there was a question Adil raised around sort of how much. How big is this going to be? Is it going to slow down? I guess if you have a very big federation, that hierarchical nature could make it practical if you weren't trying to put it at the master broker, but we're down at the kind of leaf brokers or lower, and it would be less impactful than necessarily trying to run it through all one spot.
Yeah, and I think, Brian, one thing that was mentioned early on that just registered just right now was, I mean, when you're debugging and setting up a co-simulation, you might want to enable the profiler. Once you're done with that, you can just disable it, right? And you won't have that overhead.
Yeah, it makes sense. Anyway, thanks. That's helpful. It's neat that it's hierarchical. That's a nice scalability. Also, I see Jason's continuing the conversation around that time diagram in the chat, so it'd be interesting to see how that compares to what Nathan was thinking. And I don't know, Nathan, you could always scratch something on a piece of paper and show us what you're thinking as well.
Hey, Deepak, I have a question about so obviously the Helix runner runs all these things in a background process. Is there anything built in such that it captures the output from those processes? Any types of STD, anything that particular process printed to the standard out or in error? Does that type of stuff get caught and put into separate files to, if something goes wrong, type of a logging capability type of feature or anything like that?
Yeah, so every federate standard out and standard error are put into a log file, and the log file name is basically the name that you choose for the block. So this and in addition to that, if there was an error, let's say as an example, I decide to raise an exception here. And if I try to run this, it tells you which federate has failed first, and it then kills all the other federates as well. There is an option to not kill all the other federates. So if you did want to run even though one of your federates is crashed when you're using the CLI, that's also available.
That's highly useful for me. I know I have lots of issues when in terms of co-simulation automation and being able to try and, when something doesn't run, figuring out who was the culprit and who failed and everything like that. So I find that highly valuable.
Any other questions? If not, I'll turn it back to Trevor.
Yeah, I can share my screen. I've got a few question prompts. They're very similar to what Brian was discussing earlier, so we may or may not have any more presentation or discussion, but if you do, jump in. I'll throw this out specifically and see if anybody bites. Number 4 there, the standardized interface, standardized use cases stuff. How did that strike you? Overly restrictive, not useful, could be amazing.
However, maybe we're running out of energy here at the end of the day, or at least the end of the sessions. Did you have any? Did you or Deepak have any closing comments here?
I don't. Deepak, do you?
I guess my only comment is if you do have any feedback, or if you choose to use this and run into any issues, just let us know.
Yeah, lad, we're always ready to listen to any suggestions for making Helix easier to use or other features that would make your life easier.
Thanks. And Brian?
In case people, I was just, I know I was going to only highlight that in case people weren't following the chat, thanks Nathan for sharing that picture of like a type of timing diagram. Again, may not be fully automatable, but that does seem like it's somewhat similar to the one that Jason was showing as well. So that could be an interesting piece in the future usability, following up on that conversation.
All right.
But yeah, great job.
Thanks, everybody. This does kind of wrap up the session for today. We do start again tomorrow at 9 a.m. Pacific time, where we'll jump into some more use cases. We'll focus on the ones that have been used to develop out the Helix software over the last really about 24 months now at this point. And so that'll be really exciting to see the progress of those use cases. And then we'll close out the day with a kind of an update on the developers forum. So Phil and his team will kind of walk through all the changes that have happened as we've moved towards multiple releases of Helix over the last year or so. And then we'll move into Thursday, as I mentioned, will be the TRC meeting, which will be reserved for just our TRC members at that point. But for today, I want to thank everybody for joining us. I really appreciate everyone sticking down to the end, because I know it does get to be a bit of a long day, especially across these virtual meetings. So thank you very much, and otherwise have a wonderful rest of your day.
Thanks for all the info. Have a good one.